All right, Nick. So welcome, man. So I'm here with Nick. He goes by the handle Attila the One. So he just reached out to me. We connected through the Non Sequitur Show chat box, which is a very active place to discuss things and all that. So he wanted to discuss flat Earth and ball Earth, and it doesn't necessarily have to be restricted to that. It's just getting to know another person on planet Earth. But so Nick, if you just want to kind of just say hello and what your thoughts are, initial thoughts.
Hi, everybody. So, as you said, I'm Attila the One, and thank you again for having me on here. And that's just I guess my thoughts is obviously I'm a follower of I firmly believe in a spherical Earth. I'm not a flat Earth believer. And I've got a weird theology. And that's one of the things I'd like to talk theology with you a little bit. Mine doesn't really fall neatly into anything, and I think that that's just one of the things I'd like to discuss on this a little bit. But I'm just excited for the opportunity to be here and chat with you some. So
All right, cool.
yeah,
I'm just
sorry, I'm terrible at intros.
no, that's cool. It's totally informal, man. Like I'm just pulling up. We emailed back and forth, and I just made a short list of things that I want to touch on.
Mhm.
We don't have to go through really anything in any kind of particular
Yeah.
order, but we sort of agreed like we'll just do a few minutes of just background, whatever. It doesn't have to be specific of ourselves, just as human beings. It doesn't have to be academic necessarily, but just anything that can give people context of like who we are, and then if they may want to follow your channel that you said you want to start soon, just to kind of give people some way to grip our life, I guess. So I'll start. I'll kind of do a very quick sort of run through of what got me to this whole idea that the Earth could even be something other than a ball, which is kind of the context of why we're talking, and a little bit about my academics, just because Nick and I have some similarities. He's obviously much more advanced in geology, I suspect, but I've worked in that field very briefly, so we have some common ground. But so I basically got in, like I said, in the non sequitur on my first debate. I got into flat Earth largely through Russian bids around 2014, 2015, and it started, more on the conspiracy side and the numerology and the 666 and the 33 and all that he points out, in my opinion, very, very eloquently and precisely. And then, he's into flat Earth and has been, I suspect, for a long time. And so that was the first time literally the thought entered my mind, and then I started emailing some of my friends, like, PhDs and math people and stuff. And I wasn't getting crisp answers. So, the conspiracy theorist in me started kind of going down that path since then. And so that's sort of the beginning, and ever since then it's been, just a lot of videos and watching, what's going on in the community, just like we were watching the non sequitur. I would prefer to be around people who hold the opposite stance than me aggressively, because I feel like I'll learn the most from them. Obviously, I'm very open to talking to flat earthers and people who are unsure. But and so academic wise, I have a sort of a strange background because I'm an electrical engineer who is who got a master's in electrical engineering, but then I got into like accounting and finance in the business world, and I have a master's in accounting, and most recently I'm a CPA, and I currently work in the field of accounting and finance. But I my first role was at Western Geco, which is a subsidiary of Schlumberger, and it was doing a lot of seismic data processing. So I'm definitely excited to hear more about your angle, not just the geology piece, but the the theology and all that. And I'm honestly more in this for the prophecy. Obviously, I'm very open to talking about the technicals from whatever I'm capable of. But if you have anything about God or theology or anti-God, I'm very open to hearing that. So
Alrighty.
I'll pass it over to you.
Alrighty. Cool. So that's awesome. I forgot you had two masters. It's really sweet. So
Too much school, man.
congrats. A lot of school, yeah.
Yeah.
So just to give everybody an idea of my background, I was basically growing up, I was that kid who liked dinosaurs and animals and stuff. So I didn't even learn how to read. I was late on learning how to read, and then they had they were books called zoo books, and I realized I could read about animals, and so that kind of like the whole. I've always at least kind of been into the whole science thing and learning about the world around me, and
Cool.
it's just as fate would have it. I ended up going to Appalachian State in the United States in North Carolina for a it's like a hybrid, so it's a geology program, and the degree is geology. It's with a concentration in paleontology. So
Hmm.
basically, I got a bachelor's in geology with a minor in bio is basically what it amounts to, and I got to actually do. They don't have a grad program there, so I got to actually start doing research and working on my own project and learning my own stuff. And I've got a manuscript that should be coming out of that pretty soon, hopefully get published. And then from there, I moved on. I'm in grad school now. I'm going for my master's for it's an actual paleontology program this time. But I was so excited to get away from rocks and do actual paleo. But I'm basically doing a geology project. So it's funny how the course of things will take you. But so
That's
I obviously like I'll tend to approach things from I guess a very scientific standpoint. But the I guess the one thing to consider is I'm actually and right now I don't have a good label for myself. So I wasn't really raised religious.
mhm.
My dad's kind of religious. He's not into organized religion, but I think you could just generally describe him as Christian. I think that label would fit him. And I
Yeah.
don't know if that rubbed off on me or not, but because I wasn't really raised. We never went to church or anything, and I don't think I was raised explicitly Christian. But that's just what I gravitated towards.
Yeah.
And so I actually it's not something I really thought about a lot until I got to college and I took a New Testament and an Old Testament course, and the roommate I had at the time was really big into theology and stuff, and so I kind of started to I guess explore my faith further and kind of look at things. And I guess just and so that's how right now I'm somewhere in between. I'd say I'm somewhere in between an agnostic or like a weak, if there's a weak agnostic, that and what I would call a Christian, because there's just a lot of stuff I'm unsure of. But
Okay.
I do, I definitely think that there is a possibility, and if I had to bet money, I would bet money that there was a God who created the universe. Just because I've got a couple issues that I haven't worked out yet with like pre Big Bang stuff. But I'm essentially like just to give you an idea of theologically where I come from. I would branch off of Christianity. I think before what's it? The Council of Nicaea was Constantine, right? So sometime before that, I'm like a really weird non-Trinitarian type of deal, and I reject the Old Testament in its entirety. Basically, I don't think that it has much. I don't think it has much in it that's true per se. I think most of it's stories, and I don't think if you were to describe me as a Christian, like theologically, I would have to reject the Old Testament in its entirety. I don't think God actually had a hand in any of that, etc. But I would accept the New Testament if that makes sense.
Interesting. No, that does.
And so like just I guess somewhere between that, and it's like I get a lot of the arguments where people are atheists. Like I'm probably one of the few people on the planet who's watched hours and hours and hours of Arden Raw, and I'm not an atheist. Um it's like I get a lot of the viewpoints how people end up there, and I think it's reasonable, but just for me, I've got a couple hangups that prevent me from I guess going like I probably would never actually describe myself as an atheist because
Mhm.
I don't think I'm not convinced you can prove or disprove God, but depending on the nature of God. I mean, obviously, if God's nature were certain things, I think you could definitely tell. But just from what I see of the world, I tend to think you might not be able to. It might not be something we can tell. But so yeah, that's basically that's my thing. I'm interested in a lot of subjects. I like to talk theology, though I don't know a whole lot of it, and I'm not necessarily familiar with some of the terms. And I can do as long as we don't go into like super small grain physics. Like I can handle physics. I can do geology. I can do bio. I can talk about a lot of different things. So
Yeah, that's cool. I think that just from hearing you talk, I think we have a similar approach, even if we maybe landed on different, I guess, truths for us right
mhm.
now. I definitely vibrate well with quote unquote atheists. I've always
Mhm.
been a person who feels very deeply and be reaffirmed many times that people who claim to love God a lot and remind people of it usually don't, and the people that are staunch atheists don't always resemble, you know, atheists. Like they're not as godless as maybe they come across, you know. And I think that I think people who are atheists and hold that position strongly, to me, I find I can learn quite a bit from them, you know. And I think I definitely enjoy flat earth debate in particular, like Nathan Oakley and all the other, you know, channels that are out there. But I also gravitate towards non sequitur because they'll get people on there with very, very unique stories, and they almost don't have, you know, inhibition. They're just free, you know, sharing their views. They don't have this like God hanging over their shoulder telling them to not say certain things and stuff. So that's why, you know, we'll keep this debate, you know, very open. Like I'm very difficult to offend, and if you do, you know, we'll be very upfront about it. I think that ultimately this is like the search for the truth. The one good thing about this truth is that the other shape is not changing, and so like, you know, it is what it is, and we'll figure it out with rigor eventually. And I don't think it'll take too long. But so the physics stuff, I'm honestly not like I'm not a physics major. I would consider myself, you know, well above average in math, but I'm a little bit removed from like, you know, the day-to-day mathematics and engineering and stuff. But you know, so if there's ever a term that I say, and I might ask you to clarify some as well.
Yeah.
You know, you can just interrupt and we'll you know, learn. So.
Yeah, real quick to give you, so my background with physics is I find a lot of it fascinating. Honestly, it's something I don't think I could ever do for a career. Honestly, it's just I think math's cool, but I really just some of the math that you have to be able to do, and just the concepts, a lot of them, especially once you get into the quantum realm, everything's so unintuitive. And I'm gonna be honest with you, even for geologists, I'm not good at visualizing 3D space very well. I have a lot of problems. It takes me longer to think about stuff in 3D. I do 2D really well, but I ended up having to take 2 years of physics honors. So it was basically the first physics class for physics majors. And as fate would have it, I ended up having to take 2 of those. And so I feel like at least in terms of like a basic, like here's general physics, I usually know that pretty well, but there's going to be some stuff I'm not going to remember. Like even a couple when I was preparing for our discussion, some of like and this is one of the things I'm excited to talk to you about, since you know, you should know, like, I feel like you know the electric stuff pretty well, considering you know, that was your path. And that stuff, like I'll talk a little bit about like magnetism and stuff, but I'm gonna be very rough around the edges for some of that, and that's one of the reasons I'm excited to talk to you, is because I expect you'll know that stuff pretty well and be able to, like, if I'm saying something stupid, you'll be able to like, hey, it's actually this. So
you know, it's funny, like I don't know if you saw my first debate, but I got quizzed on like a circuits question, and you know, I kind of puffed my chest out to get on the show initially, so I felt like I deserved it, but you know, that stuff, I don't even think I would be able to answer that during, you know, my course of studies. I don't think anybody would be able to. It's very specific, but anything about like electrical wiring in a house, I'll probably have a blank stare, just because that's not what we were taught. Like, and it should be more of a focus. And to be honest, I think we're not going to be that far apart on like fields, like magnetic fields, like, or even certain things about like the electromagnetic spectrum and all that. Like, I feel like, you know, that electromagnetic theory and just all of that stuff that is like not tangible, very difficult, you know, to like grasp. And a lot of times those are fields and waves that we want to avoid, you know, in our life. We're not like actively like going towards these kind of things. So we don't really like interact with them. But, you know, I think just between us, we can learn about it. It's I feel like I'm intuitive. You know, you strike me as an intuitive person. We'll keep it at that level, but I won't run circles around you on that, but certainly.
Appreciate it.
No, sorry. What was that, Nick?
I just said appreciate it.
No, I think like some of the stuff about communication systems and the analogies that I use, I'll bring up one of them in particular because I'm going back and forth with another electrical engineer who was on the after show, and you know, I looked at his LinkedIn. He's all but just dissertation, so he's close to a PhD in double. And I saw some of his videos. I'm referring to this guy, George Natchuk. and you know, he solving like op amps, you know, using superposition and all that. So like he's in the nitty gritty, and he strikes me as a person who's like mathematically inclined. So we could speak a similar language, but I suspect he's a little bit more rigorous than I would be right now. But if I ever bring up anything like that, you know, I will explain it in a way that hopefully you'll be able to, like, you know,
appreciate it,
react to in some way. But
appreciate it.
so I don't know, since you're the guest, man, like where do you want to begin, dude? We can talk about golf, even if you ever want to talk about golf. We can talk about flat Earth and God and this or that.
I think the first thing, something I was curious about, is your point about the vectors. That was the only thing that was really frustrating for me, because I didn't get to watch that show live when you were on Monsec the first time. Yeah. And so I was just watching it afterwards. I think I don't believe it was live. I was like shopping at Walmart, but I think they didn't seem. I don't think that they were getting what you were saying about the vectors. And because like and it's been a while, and I didn't get a chance. I was hanging out with the family. I didn't get a chance to watch the video again, so I could say this more, I guess, articulately. But I kind of think I get what you were saying, because was your argument essentially like because like it was having to pull things with more mass, like differentially, and so your argument was you used the word, and I'm sorry, I can't remember the word.
Orthogonal.
Not that one, actually.
Oh, okay.
It was like your point was that it was had different magnitudes, like the vectors had different magnitudes based on the objects. The word, I don't think the word was intelligence, but that's the word I'm drawing, but I don't think that was it. I don't want to like straw man you or misquote you on that, but I think, because it made sense to me how you were thinking about it, and that was something I think we probably do think about things in a very similar way, and that was one of the reasons I was excited to talk to you about it. But if I were to just like if I had been, I really, really wish I had seen that live so I could have sent a super chat in. But I think the thing that I think I would say that the difference that you're having in the understanding it between everyone else was, and I don't think that they were explaining it in a good way, because I don't think they didn't understand what you were saying, so they weren't addressing that well, basically, is what I'm thinking.
Yeah. I got no info on that, by the way. Sorry, Nick, but we can go into that. So I got some feedback from George, but you're not commenting me. What you said is actually exactly what I said. The intelligence that there would be like a magic machine in the middle of the Earth handing out these vectors.
Yeah. All right. So the thing that I would say about that is, I think too, because that was weird to me at first, is just like, you know, that is odd that different things, like, you know, they would have a different like gravitational pull, and that just seemed really, really odd to me. But I think if I were to try to explain it to you the way that it finally, like when I got through it and it made sense to me, was that if you think about it, like say like every atom, and obviously this is generalization since all the different atoms are different and they have different numbers of protons and whatnot. But like say that like each I guess each proton, like say that interacts, because the electrons are like negligible compared to the protons in weight. So say that each of the protons has a mass, right? And that maybe the way to think about it would be that gravity has the same vector for each of those protons. And when you have an object, like I've got this, the remote that controls my lights over there, the colored lights, it's got a bunch of atoms in it. And so if you were to add up all the vectors for all those atoms, you know, you're adding them up, because it's like it's the difference of, like, say you put one booster, like say you have like a little model rocket. I'm just, the first thing I'm thinking in my mind of force is like, say you have a little model rocket and you have a certain engine, and if you put two of those engines, then you're going to be adding the force that they exert. So it won't be the same force anymore. It'll be the force of both engines. I think it's probably like that. Like the vector that you're getting for this whole object is just the sum of all those proton vectors that are all the same. Does that make sense at all? I know that's probably not going to convince you of everything, but that would be like the way that, from my understanding of how you were understanding it, I really wanted to be there to be able to like maybe point that out and see what you think of that.
Yeah, I think it's good. I have to be totally blunt, I genuinely believe that it's not real, and I'm not trying to be rude. So I feel like I'm one step.
Doesn't hurt my feelings
that I bring up, but I know that in my mind as of now, and again, I'm open to learning from you, is that it's BS. But so what you said is true. It apparently does act on an atomic level, but the orthogonality is the thing that I'm nitpicking on George, because he made a really long reply on one of my videos, and so the thing that people that I'm getting from people is that that field, the gravitational field, is mathematically, similar, just in terms of the equations. It does resemble, like the interaction of 2-point charges and stuff like that. Like the formulas look similar, and they have the same, relationship, and that. So like that's one of the things that people will use as like the fact that it's symmetric, with other known fields. But the thing that's unique about gravity, if it were to exist, is that very notion that an atom is interacting with the center of the Earth in kind of an exclusive. It would have a relationship with it, and it's uninterrupted by the goings on around it. And that to me is that's one of the top things that will be brought up early in flat Earth. The water bending is also one of them, but this thing just doesn't sit well intellectually. And I think fall Earthers understand that it shouldn't, because if gravity were to exist, it would be an amazing thing, because it would be orchestrating the ability to keep, water in its place, but also allow a bird to like freely fly around and, land on it and whatever. So yeah, sorry, go ahead, Nick.
The thing I would say about that is it's not just interacting. So that take the one atom in this or whatever. It wouldn't be that it's just reacting with the center of the Earth. It's reacting with all the, and I think, don't quote me on this, I think there's some crazy thing like technically all matter is affecting all matter. It's just once you're a certain distance away, it's not supposed to be significant enough to really affect it anymore.
Right, yeah.
But so just ignore stuff that's really, really far away from, like, if we'll say, take for just the sake of argument, like you've got the sphere Earth and then you've got the remote. It would be reacting with all the other particles too. And it's just that's where the center of all those other particles, that's like the average. So that's where things are going towards. Would that make sense at all? Because I get what you're saying, because it's not like there's a magic, like it's not just the center of the Earth that would be having gravity, because like technically these have gravity for each other, my mouse and this, but it's just so absolutely negligible compared to all the like millions and millions, it's some crazy number of atoms that are going to be just below, in general. And then like the average of those points is where the center of the Earth would be.
Yeah. The M is so big, basically, in that F equals G M1 M2 over R squared. So the M in the Earth is always the biggest, always, So I get that. You don't have to kind of include those effects of like, the mouse interacting with the keyboard kind of thing, in front of you. I get that. But here, let's just look at the mouse interacting with the Earth and just look at that in isolation. So I drew a picture on my or I went through a video on my site with like, let's say you have like a U-shaped arc and then another U-shaped arc right beneath it, like a horseshoe with like a little horseshoe underneath it. And so, but the horseshoe on top is like very, very heavy, and so it would need to experience a very strong pull towards the center of the Earth to keep it, in that position. Let's just say it's just standing on its own. There's no like nails or anything. It's just heavy. And so it's staying there by gravity. And so my question, the question I posed to George and others is like, well, if there is a force that is real and physical and tangible that is actually interacting with that horseshoe, what impact is it having on anything below it? Let's just think of another horseshoe or just anything smaller than it, not as heavy. And so basically what has to happen, and I got George kind of in a corner, which he's going to have to explain, is that those two vectors, you would agree that they're occupying the same space. Let's say their center of masses are lined up. Yeah. They're all in the same line, right? Yep. And so that force, if it's real, it's kind of going through or, you know, interacting in the same column, for lack of a better term. Like, let's think of it as a
I get what you're saying. Like they're essentially like if you were to draw the vectors, they're in the same spot.
Right, exactly. Yeah.
So it's like I'll let you continue, but I think I get what you're getting at.
Yeah. So I just think of like a cylinder going through the center of mass. I understand they're acting on an atom by atom level, but let's just you know, it's technically an integral. I guess that would be solved across the whole 3D body, but let's do a pointwise replacement of it at its center of mass, which is actually technically not on the object, but they're acting in that column. And so now George in his discussion with me made the bold claim that gravity obeys superposition. And so that has mathematical implications. So the definition, just so you know, of superposition is a linear system obeys superposition, and superposition holds for linear systems. It's one-to-one. It goes backwards. So let's say you have any system, any linear filter. If you put one input in it, wait for the output, then you put another input in it and wait for the output. It's the same as putting the two inputs added together, and you'll get the output, the summation, like of what the other two outputs were.
Okay.
So that's the definition of a linear system, is that you put X in, it spits out C. You put Y in, it spits out D. If you put X and Y in, you'll get C plus D. Yeah. So that's superposition. And so that, to me, it's like if you make that statement, I'm just going to say bye to the chat. There's a couple people in there, but so if gravity obeys superposition, those vectors in that column, you could add them together, and then effectively that combined vector could replace the other two. You don't need the other two anymore. You can just have that one represent the work, the quote work that's being done by the other two. And so that's problematic to me now, because if that is true, then that new force would be acting on both objects. You know, it would have to be. It can't say, oh, I'm going to give you 75% of my vector and I'm going to give you 25%, and sort of be intelligent enough, like, you know, divide the effort. You know, superposition, which other people have now told me that it doesn't obey superposition. So I don't think George is like I'm not saying George is the godfather. I'm just using him as an example of what he's told me. Sorry, go ahead, Nick.
I was gonna say that was gonna be, and obviously this is not like the nitty gritty details of it beyond like the base physics level is not gonna be my thing. But I would have based on this, because I get what you're saying about like a linear system and superposition. I would have thought, like, based on my understanding of it, I would have thought it doesn't follow superposition.
I don't think it can. In my
I wouldn't think it, because because based on that, like, you know, that horseshoe in the middle, the smaller horseshoe,
it's gonna get crazy.
Yeah, it should be experiencing the gravity from the larger horseshoe too, and that should be something we notice. And we don't. That's not something that I'm familiar that we notice. I've never heard something like that before, so I don't actually think it's a linear system. I could be totally wrong. That's just the way I understand it. But,
no, well, and it basically can't. But he might be using it in a different context. I'll keep you in with how he applies.
I'd be really curious.
But here, check this out. Not to corner you, but now there's an issue, is that if they're in the same column and they are not interfering with each other, because that's what we observe. We do not see the inner thing, like a bunny rabbit or whatever. It's not getting killed walking underneath a horseshoe. And so now the question is, how are those forces which are co-located not interfering? And that's where I was using the term orthogonal, which I'm not sure if it went over people's head or they've only heard it for the first time, but that is the mathematical way to understand two things that are in the same potential whatever not interfering. They have to be what is known as mathematically orthogonal. And so we already know that they cannot be, and I went through different just to give you an understanding intuitively what orthogonal, like a plane flying is orthogonal to the cars on the ground.
Yeah, basically, from my understanding of it, was that it's orthogonal generally represents 90 degrees. So whenever we so any plane, two things are 90 degrees, and it's just the way of them not, like how you were talking about them not affecting each other.
Exactly. Yeah. It was like I use that term better. It's the 90 degrees is definitely true, but it's way more general than that.
Yeah.
90 degrees is a good. It's basically, you know, if you have a point on the X plane. I'll stick with two dimensions, you know, X, Y. You can move along this thing,
Yep.
and never interact with anything going
Yep.
on the Y. And so 90 degrees is good for us visually, but orthogonality applies more generally in higher dimensional space. But so just intuitively, like a plane is orthogonal to a car in space.
Yeah.
It's orthogonal in space. And like even somebody who's like doing sign language while someone's talking, they're not interrupting the other person, but they're speaking in a language that is orthogonal to the person audibly speaking. You know? So that you can communicate two things over the same medium, in this case, like visually, but not interfere with the other person. And so if you have two forces, the horseshoe and let's say the bunny or whatever below it, they're orthogonal. That gravity vector, let's say we use the centroid. I understand you have to integrate over the whole mass, but those two vectors have to be orthogonal and in some way. And we know it's not space because they're in the same column. We agree with that. Their center and masses are lined up. And it can't be in frequency because there's no notion of frequency dependence in gravity. And so now the question that I have, the $1 million question that I posed to George and you and just others to think about, you know, we're not going to come up with the answer, but they would need to be orthogonal in some way. And if they can't be described that way, that's okay too. I'm not saying, you know, rest in peace, ball Earth, but that just means you cannot characterize gravity as a vector field, which I actually don't think you can do, to be honest. Like, it's just, and it's consistent with what Neil deGrasse Tyson said, that you just can't, you know, it's like what is happening. That's what gravity's doing. That's, and I'm not trying to be rude, but like, that's the best a ball earther can say, is like what you see around us happening on the ball. That's what gravity did, you know, but to pin it down literally, like kind of literally to pin it down mathematically would be very difficult. So sorry, I got lost.
No, I'd agree. It's as far as I know, you know, a lot of that stuff, like the exactly how, it's almost like by what, it's like you're saying they're orthogonal. So by what mechanism is allowing them to be orthogonal if they're not orthogonal in space? Yeah, as far as I know, I don't think anyone knows. There might be. There's some of the guys out there who do the crazy physics, and they might know. I'm definitely not one of them, and I'm not familiar with anybody. But just to my understanding, that might be the kind of thing to ask a guy like Steve McRae would probably know, I would think. Or I know he's got that Landon guy who's supposed to be really, really knowledgeable. But as far as I know, we don't know. But my question for you would be, even if, so say we don't know the mechanism by what it works, you can still observe the effects of it. And so is your point more like I get what you're saying, like we don't know the exact nature of it, or I'm assuming we don't know the exact nature of it. I don't. And but it's something that I think we can still see the effects of. And so even if we called it something not gravity, it from what I understand, it really does look like, and I can't really go into like I can't really for gravity go into a lot of the experiments. I know I hear people throw the Cavendish experiment, and it was explained to me once, and it's not something I've used again, so I can't throw down the Cavendish experiment or whatever and be like, yo, these experiments, to be honest with you. But it's something I think you can see the effects of pretty consistently. At least in your, you know, you can see it in the small realm that you can observe things in, at least. And then from there, so that, I guess that would be my thing, is like, yeah, like that's something, you know, we don't know. And I'm excited for people to figure it out. Yeah. I know it was a big deal when they discovered, they measured those gravitational waves, a while, not too long ago. And apparently that was a really, really big deal. And so I expect, once the data from those observations gets analyzed by people, maybe they'll have a better understanding of what the hell is going on. But
yeah, I think it's possible that that it just, you know, the stance that I would have to take if I was a ball earther, which obviously I'm not, but it would have to be what Neil Tyson said, because I feel like you there's certain things you just can't explain, you know, and it's it doesn't mean that it doesn't exist, or from I'm speaking as if I was him or a ball earther. Yeah. So it's not just because you can't describe something mathematically doesn't mean that it exists. So this is a little bit of the double talk that, you know, I'm not trying to pick on you, but The ballers, you can't be raw on math and have the very force that holds it all together literally not be able to be characterized mathematically. Again, it doesn't mean, you know, give up and it's flat. It just means you guys can't come at us with like, and I'm not accusing you of this in any way.
Yeah.
You can't come at us like we're not math people when I'm actually trying to help you pin it down mathematically. And so that's a major issue. My point is that, you know, it's sorry, I lost my train of thought. Do you have a response or just whatever you're thinking?
I would say it's like, yeah, obviously, and that's once again one of the things I think you're probably is I think as far as flat earthers go, you would be out of all the ones I've seen, I think you're the most knowledgeable. I think you're a lot of them I see, the people who make videos, I don't think a lot of them are genuine. I guess I think a lot of them are taking the piss, so to speak. I don't think you are. I think you strike me very much so as someone who like wants to learn, and it's the same thing. It's you know the math, but you're capable of looking at the arguments in a way. And I get what you're saying. It's like we can't mathematically characterize. I guess like we can't make a, if we don't know what's going on that smaller scale, what's making the force work how it does, then our model's technically not actually describing it. Right, like we're simple, like our model for gravity, we're simplifying the effects of that, but there's a part we're missing. Would that be fair to say? Like we have our general gravity equations, right? And say those all match what we see, but it's like the distinction between the Newtonian physics and then versus quantum physics. Like,
yeah,
technically the Newtonian ones work, but obviously those aren't actually, you know, if there were, say that for the sake of discussion, there were actually equations, math embedded in the universe, those Newtonian ones clearly aren't the ones that are there. It's the quantum ones, because those work for both scales. And there's probably, you know, there's another level of something that we're missing because we're not exactly sure how that orthogonality works out.
Yeah.
But I would say, and like I said, I'm not going to accuse any. I'll accuse people on a person by person basis, and I don't think you have this problem. I'm sure there are people who aren't really math minded, because I've heard people say, "Oh, I don't need math," et cetera, et cetera. But that's not what I'm here to argue, I guess. But I think the important thing for people to do is, I guess, just, you know, try to learn what you can. And I'm rambling now. I lost my train of thought. But
I actually was resonating exactly with what you were saying, but I think that, and I'm not here to take out, you know, my frustrations with ball earthers, whatever small amount it is on you. That's obviously
you're not going to hurt my feelings at all. We're just having a chill discussion.
Yeah,
so.
But I know I was definitely agreeing with what you were saying, is that, you know, there are issues on both sides, and I feel like the one aspect that I do try and bring is like a little bit of the balance, because I won't be heartbroken if it's a ball, because I believed it for 95% of my life. You know, it's like it's going to be difficult. I understand the barrier that exists between a ball earther and believing in flat Earth. It's a major leap that does not make you popular, to be honest, really, with everybody. So, but the math part, my only thing was just, it's not like that means that I take the math card away from the ball earthers completely. My thing is, like, they can't be as raw about it. Like, you can't come saying that, you know, math is everything and math is explains everything, when the very force that is needed becomes a bit mystical, you know, even a little bit, even if you don't agree with my full, you know, mathematical treatise, there's some sort of uncertainty around it to characterize it perfectly. That's math.
I think that's exactly right. And I think this is a problem that a lot of people have when just communicating science in general. Every single thing is going to have a little bit of uncertainty. So as far as I know, there's nothing that we know, like, for absolute certain, there's no way possible it can't be reversed. Like, there's always something more to learn, and you can usually always go a little bit deeper. But I think, and I can't speak for all the other, you know, all the others ball earth people, but I think a lot of them, the reason that they home in on the math is a lot of the flat earth people who get into these debates, they like geometry. I know is a big problem for a lot of people. Like, they can't do, like, you know, high school level, and that's, you know, that's on a person by person basis once again. But a lot of them struggle with, like, you know, or they'll argue against, like, geometric principles, that kind of thing. And I think that's why. But I get what you're saying. Like, you know, there's still definitely more, because I'll be honest, I firmly believe, and I'll say the word believe. I firmly believe in gravity. Um,
No,
but
I
you
mean,
know, but it's definitely there. There's definitely more that we can know. So
yeah. I mean, if
we
it's a,
don't have all the answers, and I think that's something that's fine. You know, we're probably not going to have all the answers for anything ever. I don't think. If there's an afterlife, we'll probably have all the answers then, but not until then.
Mhm. Yeah, and I say this on my channel in the most recent video I posted too about uniqueness. If from a spiritual perspective, I believe God created whatever Earth it is,
Mm-hmm.
but and He would also have created the debate. So he honestly is setting this up where if we did know conclusively um, one or the other, it would be
Mm-hmm.
pretty kind of overwhelming. Because honestly, like if it were a ball, that would mean, like, just thinking sort of like a thought experiment for me
Mm-hmm.
personally, it would mean the government is not actually lying on a lot of things.
Mm-hmm.
And then so gravity would exist, and that would be an amazing thing, honestly, just to learn more about, to be honest, because that's
Mm-hmm.
fascinating. And then, just that in and of itself would become a path to learn a
Yeah.
lot, of things. And maybe a lot of the other space stuff is not BS either. And then on the flip side, for a ball earther to come over to our side, I mean, it's a pretty life changing thing. I don't think it's, you don't want to have a meltdown or anything, but
Mm-hmm.
it puts you at the feet of God. Like, to be totally honest, and even maybe more scary for some people, it most likely puts you at the feet of the God in the Bible, because it's the only one that's very kind of overt about the fact that it is supporting a flat Earth. In my view, I'm open to learning about other religions, and I would love to come across people. Maybe you and I have a similar sort of Christian background, but my family is actually Hindu, and I'm not sure what their stance is on the shape of the Earth. And I'd be very interested to hear people, even of like smaller, by smaller I mean just like less of a following, like what their opinion is. But to me, the Bible is very obvious a flat Earth book, and then so one has to come to the face with the fact that the God that highly likely created this is the God of all those stories that you mentioned in the Old Testament, that in my opinion I struggled with believing for a majority of my life. Even to this day, I find a lot of them to be like head scratchers. Like,
Yeah.
yeah, what the hell is going on
Well,
with this stuff? So I was
so
I was a New Testament guy as well. Just, this is my last point. I'm with you on that. I was for a long time. So
yeah, so I guess my thing is the parts, I guess, because the thing for me is I can see, like, I get what you're saying, that like a lot of people would probably turn to the religious aspect if they, if they were to come to the conclusion of flat Earth versus ball Earth. That's where they would tend to go, because that's, those beliefs are usually, congruent with each other.
yeah.
But my thing about that would be is I could see, I once again, I firmly don't believe it, but I would say if the Earth was flat, I don't think it would affect my religiosity at all. Like, I wouldn't, for instance, be more willing to believe in the Old Testament or anything. I would just I would have to look at a lot of stuff, obviously, because if the Earth is flat, a lot of conventional science, a lot of that's going to have to change or have to account for stuff. And so we'd need to look at a lot of different things. But especially to geology, and like I said, that's my area of expertise, and I'd like to go down some of that in a little bit, but it's no rush, because I'm just chilling. I got time if you got time, and I'm
Yeah.
enjoying the discussion, honestly. But I guess that's what's interesting for me is I don't see it as an inherently religious thing. I guess I tend, the way that I tend to do things, I tend to look at claims like just each individual claim by itself, and even if the other claims tend to be grouped together, a lot of the time I can see if they're not. So I don't know. I guess it was more of an observation. I'm not really arguing anything. I was just throwing that out there.
No, I think it's fair. I think what you might be getting at, I don't want to put words in your mouth. You might be a little bit more balanced and not trying to extrapolate too far, And I think that I'll be totally upfront, and I have been even on my follow-up debate on prophecy. I have a strong bias towards the quote unquote meaning of life, like having a narrative for why we're here, what's going on. Like, we're not just all here, working our corporate jobs and slave. Like, I haven't thought of that at a young age, but now more than ever, I have a strong bias to have a narrative. And that, I would say, doesn't cloud my analytical judgment. Like, if someone made a baller proof that was just so airtight that like
Mm-hmm.
you have to literally be a pathological liar to like deny it. I wouldn't go there.
Mm-hmm.
You know, it's
Yeah.
like I'm not like that. But you know, I feel like I would be balanced and appreciative, you know, of people who are
Mm-hmm.
going to the level of rigor. And it hasn't gone there yet on both sides, to be totally fair. Like the uniqueness, the exclusivity of the solution is not there on both sides. There are observations that support both. And again, in my opinion, I believe God did that. He would not create a deception, whether you think it's the flat earth deception or the ball earth deception. He would not leave them, quote unquote, hanging, you know, give them something to hang on. So, you know, that's fair. You know, we don't have to take this to religion. I think just to give you a sense of like, obviously you probably know from my channel, I believe like in Bible prophecy and we're in the end time, all that kind of stuff. But there's a chance that it may not. And I would actually say the growth of me as a person in the last few months, especially with the feedback I get from YouTube, is I can't be a person who gets too far ahead of myself in terms of definitely not prophecy and even with math and science, because I can't prove to you right now that the earth is flat. I cannot, you know, like just like you cannot prove to me right now that the earth is a globe. Like you could give me directions to go to look down and all that. And that's really what I think this dialogue is for. But you know, that's you know, I think that's okay. I think it would be overwhelmed if we knew. Honestly, if the earth was flat and we all knew it with 100%, I'd literally think like, I mean, it would be, the world would like be on a standstill, you know, figure out like what the hell, like why?
Yeah, there'd be, if it turned out it was flat all of a sudden, like, and everyone just knew it, that would, I'd be scratching my head. I'd have to go back. I'll be honest with you, because you know my future job essentially, I'm more paleo than geology based for what I want to do. But even my future job would, you know, I'd have to really look at stuff and be like, oh man, is this right? Or do these principles still hold true? Do these principles hold true? Like, can I apply this here? Is that right? Is that wrong? Like that kind of thing. But
You know what, man? Like, I wish I knew some of this stuff, although it would be scary when I worked at Western Geco, because, like, you know, there's like petrophysicists, geologists, seismic engineers, like people who do the data acquisition, you know, who would understand different adjustments that would need to be made for curvature and stuff. Like, I don't know if I'd be able to ask them in a corporate setting about these kind of things, but, you know, I can maybe, you know, we can kind of pick each other's brain now. Like, what kind of things do you see that in your field that support that?
So there's really, so for just and I'll be for the most part talking about mostly geology over paleo.
Yeah, that's cool.
But I mean, honestly, the big thing I got it broken down into three things really, and we can go down whichever one you want. There's I think plate tectonics. I don't think that's something. I think that's something that's clearly demonstrated, that you can clearly see, you can clearly witness is happening, has happened. And and this is the one that I would consider the weakest out of all of it, because I'm sure somebody could propose some sort of plate tectonics that would work on a flat Earth. I don't think it would be weird with Antarctica. But like a lot of plate tectonics depends on it being a sphere, and really plate tectonics might actually be more well supported than something like evolution, for instance. Like Aaron Raw, I like the guy. He likes to throw around like evolution is the single most successful theory in all of science. I would throw down plate tectonics as probably more well supported, but so like that would be a big one, I would think. Also just how like the Earth's magnetic field, I think that has a lot of interesting implications. I don't think that the magnetic field is possible on a flat Earth.
Wait, sorry, Nick. Can we go back to the tectonics thing? Just
yeah, go for it.
Just a bit of just to pick your brain on that. So, is that are there basically like kind of research papers that are kind of predicting that, and it's coming true kind of idea, or like
yeah. So if you want, I can give you kind of like a brief history.
Yeah.
Kind of thing. So basically, like back in the day, nobody really had any idea, honestly. Like everyone just kind of thought that, you know, things were the way they were. They weren't sure. They knew volcanoes happened. They weren't sure how mountains formed or what happened. They didn't think there was any movement. And this guy, I think his name was Alfred Wegener. He noticed, he was looking at fossils. And I probably do you know if we can screen share? on this?
I've I've never done this. You might be able to. There is a
Um.
button that says screen share.
Oh shoot. I might not have it. I don't see it, but I've this is my first time using this for a while.
No, it's cool. If you have links,
Where are you
actually,
seeing the screen share?
I see a button on the left. Maybe it might be only me.
Ooh, yeah, I see it. If you can, if you don't mind, I think I've got a picture. Yeah, I do. I've got a picture I can show off for this to kind of like show you what the guy noticed.
Okay.
And so basically, all right, now I got to get back to the internet. I promise I know how to use a computer. Thank you for finding that button. So,
No, this Hangouts is new for me, man.
yeah,
So
I'm so much more used to using Discord now. So basically, the guy showed
oh,
he
here we go.
noticed,
I see it.
yeah. So and this is the figure you'll see. He noticed that a lot of these different fossils they had really odd distributions. And so he was the first person really to propose this. And so like you'll see like the different bands, like those are the ranges of fossils. So
Hmm.
something like Cydignathus, like the same exact species of Cydignathus, they'll have those in parts of South America and parts of Africa.
Hmm.
Like some things were in Africa, India, and Antarctica. Some fossils they find South America, Africa. And he was looking at these and he thought it was really odd that people were finding these things on separate continents, because this is before like they had a concept. How do I turn off screen sharing? So this is before I guess they had like the concept that these animals were like able, like, if the continents don't move, the animals would definitely have to be like, it's odd that you would have the same exact animal in South America and Africa, because it's like, how did they get to both of them? And so there's more than this. Those are just the big four that tend to get pointed out, and they use those to teach people in school. And so I just happen to have the figure readily available right there. But he noticed that the continents looked like they fit together superficially.
Hmm.
And then when he combined that with the ranges that he was finding, where the continents looked like they fit together, lo and behold, when you put them there, the places where the fossils are appearing line up. And
Hmm.
so he proposed, it was called continental drift at the time. And he was just like, hey guys, I think the continents move. And pretty much that was all he could say. He didn't have a mechanism for it. He didn't understand how it would work. And basically nobody believed the poor guy. He died and everyone thought he was just a dumb fraud. And eventually more and more evidence came together. And so like stuff like mountain ranges in North America and really big in Scotland, some of the highlands.
Hmm.
The mountain ranges line up where the continents look like they would fit together, and it's that so airtight, like the chemical, like it's not only the same rock types and the rocks are the same colors, but it's like down to the same like mineralogy, like on an elemental level. Like some of these rocks have like very like way precise similarities of like hydrogen elements, and like hydrogen or trace elements is a lot what they use for a lot of it, I believe. And so there's just eventually they never knew how it worked. And then I think it was in the 50s or 60s they ended up they were looking in the are you familiar with the concept of a mid-ocean ridge?
No.
Okay, so that's basically if you look at a map of the world, flat or otherwise, and you look at a height map, there will be shallower water right down the middle of a lot of the oceans. Like there's a really big one in the Atlantic, and it's called a mid-ocean ridge. And so what's happening is there's magma coming out of there, and so it's just a big line of like a bunch of volcanoes and stuff. So Greenland is actually, or no, excuse me, Iceland. Iceland's right. It's really weird, and it's got a lot of volcanoes on it, and
Hmm.
it's right along that ridge where you've just got land, and then all the rest of it's like undersea volcanoes and stuff. And so what they realized is that that's spreading. And so the way they proved it was spreading is they looked at they were collecting rock samples from the bottom, and you can look at the any minerals that are magnetic. You can look at how the minerals are aligned. They'll line up with the Earth's magnetic field. And what they notice, have you heard of like magnetic pole reversals before?
Yeah.
That so they looked at those, and what they were seeing is every once in a while, as you got farther from the ocean, from that mid-ocean ridge,
Hmm.
they were seeing those reversals, and they were mirrored on either side. And so it appears, for all intents and purposes, that the mid-ocean ridges are kind of, you know, making new land, and the old land is getting spread out over time. Now that's going to invoke at least some deep time, depending on how you interpret the dates. But so that's basically that's like a really quick, super brief rundown of some of the evidence
Oh,
for
wait,
plate
and
tectonics.
that reversal you're saying implies a ball? Or where? Sorry, where is the implication of the ball?
So just for plate tectonics to work like it does, essentially.
Oh, okay, got it.
And so like so basically there's just like super brief. I'll try to not ramble on about it. So there's two different main types of crust. There's oceanic crust, and then there's continental crust, is what they call it. And so basically continental crust is like, you know, North America is mostly it's called what's called felsic minerals. And so it's minerals that tend to be lighter in color and they're less dense. And because the continents are, and it's a little more complicated this, but I'm simplifying. Basically all the stuff at the continents where they're together, the rocks are less dense. And so they're, for all intents and purposes, they're floating on top of the more dense continental crust.
That makes sense.
Continental oceanic crust.
Yeah, so I guess on a flat Earth, they would like the Earth would literally be expanding. I guess technically, like it would be bigger. Yeah. Okay. So
so it would actually be. I tried. I couldn't find any flat Earth maps where they actually did the tectonic plates. I found one that was inaccurate, I think, and then there might have been one that was at least what I thought would be accurate. But you run into a problem with Antarctica there. And so do you, just because I'm curious, do you accept like satellites, or do you think satellites are a...
Dude, you literally just read my mind, because I was just thinking in my mind, what are some of the strongest baller things that I had struggles with? As when I first left Rice, I got a job offer at Schlumberger and another company called Viasat in San Diego, Carlsbad, and the owner is a Rice alum, and you know, they have a secret facility that you need certain security clearance to get into, so that kind of gets my conspiracy juices flowing. But that is hard to imagine, honestly, that a company like that would be having that many employees and just not truly doing what they're saying, you know, via satellite. But so I can't make a conclusive statement. I'm not trying to avoid, you know, your question.
No, that's fair.
Yeah, I just don't know if I've done enough on what's out there, what's been observed, you know, by either side.
I appreciate that, and I don't know is an honest answer, and I think people are hesitant to give that sometimes, or like you don't think you have enough data. That's fair. GPS is one of the big evidences of the plate tectonics, and so the thing I was going to get into is that basically you can measure where the continents are moving now and the rates of that with GPS. And what they've done with that is and like I said, whether or not you believe that the satellites can do this it's whatever. If you don't, there's probably nothing I can do. I can't like show you a satellite. Like, I'm not Superman. I can't like fly you up there or anything. So it is what it is. But I'm not going to get upset about it or anything.
You probably wouldn't be talking if they've done that. So,
yeah, if I could fly around like Superman, I don't think I'd be on YouTube at all. I'd just be making millions doing something, like charging people like $5 to fly them across to places instead of like a plane or something. But basically what they're getting is, I have to go back to my notes here because I wrote it down so I don't forget. Essentially, one part, because Antarctica is on a sphere Earth, and what pretty much all geologists will believe, Antarctica is a continent. So there's rock underneath the ice. Like people have gone there and they found like dinosaurs and stuff, and they've collected rock samples. There's rock there up underneath the ice. And so on the flat Earth models that I see, they usually Antarctica they have is like the ice wall or like a big ring. Is usually what I see for that. And the problem is, and it's really hard for a lot of people, and it was hard for me to visualize it for a while. So everything on a ball Earth model, everything's moving around on this globe, right? And so everything if everything's moving, most things were going to have some sort of a net movement. And Antarctica's net movement, so all the continental plate, or I guess the plate that it's on, is part continental, part oceanic crust, and it kind of circles around the continent. And it's spreading on all sides of that. which sounds really really weird, but essentially it's not spreading at the same rate everywhere, and so its net movement is towards the Atlantic Ocean.
Hmm.
And so on most flat Earth maps that people come up with, you're gonna have the really weird problem where it's like the flat Earth is like it's gonna have to. Does that make sense? Like you've got like this part of Antarctica and this part of Antarctica should both be moving that way.
No, I agree. There would
That's
be no
essentially what's happening.
uniformity. It would be hard to explain
Yeah.
arm movement. Yeah, I agree. Yep.
And so that was just one of the points about like the plate tectonics. That kind of thing. You get a lot of those, and it's all powered. It's supposed to all be powered by convection currents,
Hmm.
and I don't know how you're going to get those convection currents to work on with a flat Earth model. I guess this gets into the thing with if the Earth really is flat, right?
Hmm.
There's still, we're still observing these things, and so if we find out tomorrow that the Earth is flat and like someone's absolutely able to conclusively prove that to me, I'm still going to believe in plate tectonics because I've verified that these things exist on my own. Like I've gone out and all the predictions that plate tectonics makes, I can go out into the field and observe the predictions of. Like I can go to Hawaii and island hop the chain and date like okay, so the older islands are this way and they're smaller and they're made out of volcanic material and they gets progressively bigger towards the big island, like that kind of thing. But I guess it's just I don't see how, and someone might be able to come up with a model of it. It's all dependent on the ball model, if you will, the spherical Earth model,
Hmm.
because you've got those convection currents and everything's connected to something else. You don't have like with the flat Earth where you've got the edges. You don't have anything like that on the ball Earth model, and I think that those edges would really really wreak havoc with any sort of model for, I guess, deep plate or under beneath the Earth movement, essentially.
I have a feeling that's why, just from you saying that, there's people who probably support the fact that there's land beyond our edges because
Mm-hmm.
it would be difficult maybe to capture those edge effects that you're talking about because
Mm-hmm.
they would literally be edge effects that would be awkward or maybe impossible.
Yeah.
So honestly, that's a new thing for me, just hearing what you said to think
Mm-hmm.
about, because there is almost like a conservation of space. If something is physically getting bigger,
Mm-hmm.
one would think that would be potentially an issue on
Yeah.
flat Earth. But um, okay, this is a bit anecdotal, but I did,
Mm-hmm.
when I learned about this flat Earth idea, I started emailing everybody I knew kind of
Mm-hmm.
violently. And so I have a friend who I didn't know that well, but he worked for, I believe it was called MITRE, and then
Mm-hmm.
they do like plane optimization algorithms. And so I emailed him and I'm like, just simple question: is the Earth flat?
Mm-hmm.
I got crickets in response, and so he probably thought it was ridiculous. But what I think, if someone were to be in a field like working for Viasat
Mm-hmm.
or doing maybe more for like MITRE, doing like optimizations for like plane routes and stuff,
Mm-hmm.
you would need to know what coordinate, what the physical structure is beneath you. A lot of the stuff, the research, and I'm just throwing this out there as
Yeah.
if it ends up being flat, a way that all those papers could still hold validity.
Mm-hmm.
It would just be probably a conversion of a coordinate system. It's like instead of spherical coordinates, it was initially like a plane,
Mm-hmm.
regular XYZ, and then flat, and then it got converted to three-dimensional spherical coordinates, and then they're just going back and forth between coordinate systems. So that's just one way that all that stuff could still work, but it's being presented outwardly in a ball Earth sort of
Mm-hmm.
coordinate system. So I don't know the way it works with him. Like one would think that he would know, because if he's mapping plane routes, he would be one of the people in the most kind of, even I would take his opinion better than a pilot, because
Mm-hmm.
a pilot is still at the mercy of like his eyes and like visibility and you know
Yeah.
perspective, all those things that both sides can complain about, right?
Mm-hmm.
But if this guy's coming up with freaking like algorithms to like fly a plane from here to there and then this much fuel and like make sure
Yeah.
it's not wasting fuel,
Mm-hmm.
he knows the true path. He's not just
That's
taking an approximation, or we'll just assume it's flat, or we'll assume it's a ball.
yeah.
So he's moved on from that role,
Mm-hmm.
but I feel like that is difficult, honestly, for me to digest. It could be hidden that well, and then that to me is where I'll answer certain questions, at least in my own mind right now, temporarily. Is that God has orchestrated the deception and He would do it well, but like the satellite thing and this plane thing, yeah, it is hard to believe that that could potentially be not true. Like that a whole company like Viasat could actually just be dealing with ground-based satellites, which they do. They're open about the fact that they have ground-based communication systems. That's one of their deliverables, but they would have to potentially be hiding the fact that none of them are in space, at least the way that we think that they are. Kind of.
Yeah. It's a shame the dude didn't get back to you. That'd be, it's always a shame when you ask somebody something and they don't get back to you, especially when it's someone, like you said, you would expect that's the person who would know, and then you just got crickets. It's a real shame.
Yeah, he's not my close friend, and I think that was early enough in the game that might have not even have heard of it from anybody else. So people reply to me and they're like, "Is this spam? Did someone hack your account?" Which I find funny, like, and I don't get angry because it sounds like spam, to be honest. Like when I first heard of flat Earth, it was like tequila on like some gossip article. I'm like, what the like why? And I was kind of angry, like, how did she even get in the news? Like, I think she's like an ex-porn star or something. I'm like, why do they even let these people talk? I was like, so I get it, I get the resistance to it, especially with the way it was presented to me. It was ridiculous. But I think maybe he's come across more people now, and maybe he's out of the field, and if I were to reapproach him or someone like him, and this also is anecdotal, but I do have close friends that are pilots, and they have confirmed to me that they don't account for curvature. But again, that doesn't mean that it doesn't exist. It's just that could be the electronics are fixing it. But
honestly, I was gonna say that's a lot of stuff. For a while, and I obviously don't know much about it as them, but I wanted to become a pilot. I wanted to join Air Force, and I wanted to fly fighter jets. And I got turned off of it. So besides the fact I'm too short to fit in anything, pretty much.
Oh, interesting.
Yeah, I'm like 5'3", and so like there's a height requirement for the planes because they don't want to have to make a bunch of different seats, I guess. And so I was too short to fly anything that I wanted to, and so I ended up not doing it. But that was a big thing. Is it really like they have electronic systems now that will disable you from doing crazy stuff. So like probably some of the maneuvers that people probably used to do back in the day that were dangerous that might like knock you out. If you try to do those, from what I understand, the flight computer can actually veto that and be like, nope, not happening. And so that kind of turned me off from it. I don't like the idea of being in a big metal box way up in the sky that could explode and not having the full control of it. Even the computer's got my best interests at heart.
Agreed. Yeah, that's freaky, man. A lot of respect for people who fly. My friend who did it the amateur way, it's a pretty major experience to do that and to command a craft in the air. He brought his dad up, and it's scary. He said there were moments where he really had to like realize that his life and his own life was in his hand. It was scary stuff, but yeah. Okay, so maybe I can hit you with a couple points that I got.
Alrighty.
You saw the list that I produced. Maybe we can use that as a springboard. So, sorry, my Gmail refreshed. Let's see.
Yeah, let me pull it up too, so I can get a look at it as well.
We don't have to go through all of them. I mean, if we can dialogue, whenever. I think now that we figured out Hangouts, and if you have questions or learn something, I'm open to, we can discuss it. But
I think that'd be really cool if just every once in a while, like even if it's just like every couple of months, we can hop in and just chat. Because, like I said, I like talking to you a lot. You're very pleasant. You're not an asshole. There's people on both sides of this who don't have that going for them. So
you will probably notice, though, I am a little bit of a prick, to be totally honest, and I'm not. I try to not do it, like at a hair trigger. But I do feel, especially people who come on my page, that's like literally someone coming into my house. Like I want to like make sure that people who are coming to my house, like it's like there's decorum, and I get accused of deleting posts, and I do, and I just want a certain vibe, to my page and stuff. But Yeah, I mean, for people, and you strike me as the same, who are just strictly trying to learn. I don't think you will be heartbroken or like suicidal if you find out it's flat, and I won't be
Nah.
suicidal if I find out it's a ball. I will just revert back to like before, and in a way, I would be able to reintegrate into society much easier. You know, it wouldn't make my life harder, like
Yeah.
now in the here and now. To me, it does call into question the validity of the Bible, which I've spoken about. I'd be able to deal with that. I mean, I've gone through phases where I found the Bible ridiculous, and I don't find it that way now. But there are aspects of it that are difficult to understand. But so the thing we went through the gravity vectors and stuff. I think that's an open topic. You know, we can maybe revisit if there's information that you find I find that's compelling down the road. The one thing I wanted to talk about that I didn't get to bring up in the non sequitur was this concept of outer space and what is out there. And a point that I wanted to make, which is also mathematical but not too mathy, is that you know, the concept of like, first off, having like, you know, air pressure without like an enclosure, that's a very strong point that I hear, you know, from other people, and I think that's compelling. But let's remove that for now. The notion of the fact that you could like go further and further away from the surface of the earth and then experience a vacuum. Do you have any like thoughts on that? Do you subscribe to the fact that there is a point somewhere out there that there will be no like air pressure?
Yeah, I don't think, I guess, no air. I get technically it's no air pressure. Yeah, I pretty much I guess just the general conventional like understanding that most of the sphere Earth people will have of like space and what's in space. I think I would tend to agree with. I don't have any like problems with it or anything. I think that people tend to not. It's something I think people tend to have a hard time thinking about, because I mean, honestly, the concept of actually having nothing is pretty wild. And a lot of people, you know, our experience is on the Earth. And so in our experience, like gases act a certain way on Earth, things act a certain way. And so a lot of people, I think they have those notions and they try to extrapolate them out to what it would be like in space. Like the idea of, I've heard like people say like, oh, well, how do you have an atmosphere next to a vacuum?
Yeah.
And that's because like I guess like on Earth, like right here, that doesn't necessarily work because they'll mix. But there's stuff what.
Oh, sorry, Nick. My point is so the gas pressure, you know, next to a vacuum, from a purely mathematical perspective, and Red's rhetoric admitted that it doesn't go to zero. Like there's no like point where there's like pressure and then it just like abruptly goes to zero, which again, I'm not trying to pick on you guys, but that is mathematically impossible. It's possible with some physical barrier, and I guess, you know, if it were the case, it would have to be gravity that is creating that delineation between like air pressure and non. But purely, oh, sorry, go ahead.
I was gonna say, I'm sorry. What are you saying is mathematically impossible? I didn't. Is it the having the nothing next to not like a gradational nothing?
Yeah.
Is that what you're saying is impossible? Okay. Yeah. So like having like 20% atmosphere here, and then that shit just stops, and you've got 0% atmosphere here. That's what you're saying is mathematically impossible.
You can't do that. Like it's you can have it, but it has to be some kind of enclosure. Like it has to be something physical that's doing that, because that is a non-physical thing in our human existence. For something to literally go from 0 to 100, you cannot buy a car that will go to 100 immediately.
It's my understanding that it doesn't. It's my understanding that it is completely gradational.
Okay, so I think so. It's basically, there has to be, for as far as someone is measured, there has to be some amount of gas pressure. There's molecules. It always has to be, even if it's a small amount. It can never go to zero. So it looks like, you know, ballers, and I'm not trying to lump you in with them, just trying to get your perspective. But like, to me, it's mathematically impossible to have that kind of change unless there is some firm thing, or gravity is doing it. But then we need to understand at what distance radially is that happening, and why. Like, why is gravity kind of giving up at that radius? So, but if you subscribe to the view, at least what Red said, that it never goes to exactly zero, then at least it survives. Basically it's a derivative. You cannot take a derivative of something that goes from something to nothing. That's infinity, and
Yeah.
that's just not there. There's no
Yeah,
math.
I would tend to think that it doesn't go to apps, or I guess like pure zero. I would tend to think it's not quite that. It's like you said with the derivative. It probably approaches zero.
Fair enough.
Never quite. I don't know that for sure. I could be wrong, and people could think that it's goes from the whatever, and it's like, yeah, here's the 0.02%, and after that it's done. Um, I don't know. From what I understand, there's supposed to be just random particles of stuff flying around in space anyway. So I mean,
no, that's cool. My point is that
mhm.
I'm kind of hitting people with the math, like just keeping
Yeah.
both honest, but especially with the gravity orthogonality, which we can revisit. But also, if it ever does come out that it goes to zero, again, that doesn't mean Ball Earth is dead. It just means I'm gonna nitpick, and because that to me is a phenomenon.
Yeah.
I would need to zoom in on that interface and understand why, because it's not physical in signals. For example, in electrical engineering, if someone told me I made a perfect pulse form, waveform with op amps and transistors and stuff, like that would be a Nobel Prize winner every year for the rest of their life. Not physical. You have to have particles that are in two places at once. That just defies what we know. With our understanding of physics. But okay, so that's cool. I think that to me is also still a little bit of an open issue, even if it does go to zero. It's kind of like why and at what radius does it start dropping, and that kind of thing.
I think I could answer the why.
Okay.
I think I can answer the why. I can't tell you the exact radius at all. I do know people, you can observe that they're at least, you get higher up and there's like less oxygen in the air, the atmosphere is thinner. Obviously extrapolating that beyond whatever mountaintop you go to is another beast entirely. But I think the reason why would be once you're getting out to whatever distances you're getting out, the Earth's gravity isn't going to be the primary driver anymore. That starts getting less compared to other things' gravity. So like usually in our solar system, it's going to be the sun. Essentially, is like that's really like you're either going to be getting affected for the most part, unless you're right near a planet. You're usually going to be feeling either the sun or something like Jupiter, just because they're both supposed to be huge. So it would be like that kind of thing. Like when it's getting thinner, it's you can only like say you've got all those particles, you can only bring them so far down, right? Like they're not gonna, without sufficient force, you're not gonna be able to compress them in any further, and so things just end up further out. I'd be totally wrong. This is just my understanding of it. So if there's any like people who know atmospheric physics better than I do, please wreck my shit on it. But this is my understanding is you've got that limited space to hold those particles, and so then and as you get further away, the gravity it's less and less because you've got that distance, and then just eventually you reach the point and I don't know where that radius is, where you're out of what would be the Earth is the primary driver, and you start getting into where the sun's gravity would take over, and you get pulled out going to something else. That's my understanding of it. If that makes sense to you at all.
No, that seems reasonable. I think that's implying that the superposition holds. So I think that supports George's point that there has to be some notion of each atom experiencing gravity from all directions. Like it has to still be the summation. But I also get your point that when it's close to the Earth, that's the one that dominates. So I get that. So yeah, there would be some distance that it goes out, and
I wouldn't say that needs superposition. Just because the ones on the top have a different vector, they have the smaller one, but theirs is a function of distance, and just because the two hydrogen atoms can't occupy the exact same space, and so obviously they're going to repel each other just a little bit anyway. They're not going to be able to just straight up occupy the same space. So just by virtue of having that atmosphere, other particles that try to get added onto it, if that just say it's not actually mixing and that they're all just sitting in their spot, you're gonna end up having some that are just gonna have to be higher up because they got there later or whatever, and they're not gonna have that same, since they're farther away, they're gonna have that the less pull of gravity, and the farther up you get, there's going to be less and less, and eventually there's just not going to be enough gravity to actually hold it to the Earth. That gets overpowered by something else. So I wouldn't say you wouldn't need to accept superposition for gravity there, because you're not no, I see what you're saying. Never mind. The vectors are still the vectors are superpositioned.
Yeah, exactly.
The particles aren't. I got you. That's my bad. I misunderstood what you said.
Experiencing a more local gravity field from another object that is more powerful, more imposing.
Yes.
It's not like it's forgot the other one.
Yeah.
And you could.
I misunderstood. I'm sorry. I went off on a tangent for no reason.
No, it's basically that it's not that it's linear, and maybe linear and nonlinear is better. Let's just stick with that. It's linear. You can add the forces, and it's experiencing a net force from other bodies or around it. It's not a nonlinear thing, which adds a lot of complications to model it, and so that's fair. So I think that would be that would kind of have to be the explanation. But if it goes to zero, that's I think you and I would agree that's only possible if there's a rigid barrier in place to separate the two different. One of the guys on the flat Earth debate, Anthony Riley, I like those guys the way they think. He calls it a membrane, but basically some interface. You don't have to call it a firmament if that's people religiously, but okay. So I'm cool with that. So I don't want to hog it. If you have any questions or thoughts, I'll have maybe 2 more points if you're open to those, and then.
Yeah, no. You mind if I throw one more?
Go for it.
One more geology. Like maybe we can both do 2 more, because I've got essentially like 2 more geology points, and one of them's probably shorter than the other. They're both probably not going to be as long as plate tectonics. I don't think I need to go into as much background of them. So are you said that that company that you worked for a little bit, they were doing seismic stuff?
Yes, sir. They were the second largest in the world, I believe.
What were they doing with the seismic stuff? Like
So
like what kind of seismic, I guess?
Yeah, it's so they would do on land and offshore seismic surveys. So they would literally put like some explosive in the ground, and then create like sound waves, and then they would record it with different patterns, and there would be research behind what is the optimal orientation of their speakers, or their mics, like what they're listening to. So that data would come into our location, one of the few that they would have around the world in Houston. And then whatever, huge terabytes of data. And so we would first clean it up, like do a lot of like denoising, demultiple if it's like, in the ocean and stuff. Like there's issue of like signals, bouncing across different layers, which you would get. Yep. And so, we have to remove all those effects. And then the signal comes to us in the time domain, because that's the way it's captured in time. And then one of the final steps would be a migration, which is basically taking like almost at the kind of point level, positioning that to its true point in space.
Already.
Velocity model, which is where the geologists would come in. They would have an understanding of the I don't know if lithology is the right term, but like the way the ground is. And so they would have an estimate of what the velocity model is, and then that will be needed for the migration to happen. And then you would reposition each time domain sample to its estimate in depth, and then you would literally have an image that the oil companies would then drill and all that.
That was going to be my next question, is were they like looking for oil? Okay. Yeah, I didn't work for a company that did that, obviously, but when I did the university I went to graduate, we had to do a field camp. Yeah. And so I had to spend 6 weeks out, and I learned how to do like a bunch of mapping and stuff. The field camp I went to was special because they dedicated 2 weeks to learning trade stuff. And so I got to mess around with the oil-based side of stuff and a little bit of the seismic stuff too. Yeah. So cool. So you're basically, that's good. That means you're pretty familiar. I definitely think you'll know what I'm talking about with some of this then. So, like they have seismic stations all over the planet and stuff where they can like whenever an earthquake happens, for instance, that's going to put off seismic waves, very similar to, what they were doing when they were causing their explosions and causing seismic waves.
That's like a natural explosion, basically. Yeah.
So like you've got those, you got that energy being released. And so there's waves, and there's different types of those waves. And I want to make sure I'm telling you this right. So there's surface waves, and then there's body waves. And it's exactly what it sounds like. Surface waves only propagate along the surface, just because of the type of movement that they are.
Yeah.
And then body waves propagate. They can't propagate on the surface. They go like deeper in to the ground. So all the stuff that they were doing with their all their stuff that they were analyzing body waves almost certainly for most of what they were doing. And so in those body waves, and I'm gonna screen share real quick for you.
Yeah.
Let me open this up. So there's P waves and S waves. And so P waves are primary waves and S waves are secondary waves.
Mm-hmm.
And the primary waves they're called that because they're faster. So those get to places first, and then the secondary waves follow. But because of the movement, the different like style of movement in them, S waves can't travel through liquids. So you can never get an S wave to propagate through a liquid, but you can get primary waves to do that. And so this guy in 1906, he was looking at a bunch of different like large earthquake records and looking at the different seismic stations around the world. And what he found was this really, really weird and you can usually tell the difference between a P wave and an S wave based on I think the relative strengths and when they arrive.
Yeah.
Well, what the guy noticed is that there was a essentially like S waves only reach so far around the world, but it wasn't because like in a ring on a map, essentially like they would only reach so far around based on like how far they were getting. And it wasn't like a thing where it just gradually got weaker. They were getting really, really strong S waves, and then it would just kind of cut off. Mm-hmm. And they had a similar phenomenon with the P waves, except with the P waves, what was happening is it was like there was a ring, like it would be a certain, I think it was like 140 degrees around, like 140 degrees if you map it on a spherical, like a flat plane, 140 degrees out from the center, you get a ring where there isn't any, you're not getting those P waves, but then all of a sudden beyond that ring, farther out, you're getting them again. Mm-hmm. And so he was like really, really stumped by this, and he puzzled over it for a while. And that's actually when the idea of the there's like a liquid, like the core of the planet, the idea that there's a liquid outer core. And so essentially this is one of my things is this is something that I think could only the S waves could happen on a that could probably happen on a flat Earth. I think you would tend to see them weakening and then going away. But the P waves, you've essentially, like if you take the where it says the P wave shadow, you can imagine how if you were to put that on, like compare that to like a flat Earth. If you had that and you projected it onto a flat Earth, you'd essentially have a ring around, like a ring some distance away from the thing where you're not getting those P waves anymore. And essentially the guy figures what's probably happening is, since we know that those velocities, like what the company was working with, like what you can tell, and it's all off of refraction when those waves change velocities based on what they're going through. Mm-hmm. And so that's how this guy concluded that there was a liquid core that these S waves weren't going through, but the P waves were getting through. And then the reason that they weren't going through and that you have this P wave shadow is essentially because the way that refraction actually works, the angles of it can't allow them to they can't physically be where that shadow is. And that's something in particular, when I came across that evidence, that was like even more, I guess, even more damning for me for the kind of flat Earth thing, just because I don't think that there's any way you can have something like that where the waves would kind of disappear and then reappear like that, and keep any sort of homogeneity within. You could do that if you don't have homogeneous under what's under the ground. I don't want to call it a core because it's not a core if it's flat, if that makes sense. Yeah. But like you'd need vastly different you would need vastly different compositions, and you would need some spots to be liquid and some spots to be solid, and there would be like, you just have this weird ring of liquid, which wouldn't really make sense with anything else that we know in geology. And I kind of wanted to run that by you and see what you thought of that. I'm since you've got at least a little bit of the seismic background, but that was one of the things I found that they've used that kind of led to this conclusion.
Further, Nick, I've never heard that before. I can definitely appreciate the rigor of that, because I know that seismic is definitely an art, because we're not getting it down to perfection, because we're at the mercy of those velocity models and the quality of the data denoising. But Do you know if, and not to put you on the spot, but
Mhm.
does that analysis kind of reaffirm the radius as well? Like, do they have a prediction of the depth and all of that
Um,
stuff?
I don't remember. I know he. Yeah, I know. I was actually reading through the paper. It's long and it's dry, to be honest with you. And it's just old enough. It's 1906. It's just old enough. He kind of writes a little bit flowery, but not in a good way.
Mm-hmm.
And he did predict that the liquid core was 4/10 of the Earth's radius. So I don't know if he used that. There's I be sure that there are other studies where they've looked at that kind of thing and they've tried to calculate a radius off of it,
Mm-hmm.
just or I guess a diameter, just because that's a really easy publication for someone if no one's ever done it before.
Yeah.
And scientists are all about easy publications. They can get their name on something free for a year.
Mm-hmm.
I don't think he did that, but I haven't finished reading his
No, that's
paper
cool. We
all
can.
through,
I
so
don't want to put you on the spot. You don't have to memorize
no,
papers.
no, it's a good question.
But I think if you do and we reconnect, that would be cool. If you send it to me, I'll try and
Yeah.
put
No,
my.
if you want, I'll send it over right when we're done. I've got the paper. Have fun with it. That dude's a dry writer.
Yeah, I mean the geophysics is people think of oil and oil and gas as such a kind of barbaric thing, but the sophistication in that in and of itself, it's complicated. You're
Yeah,
dealing
man.
with waves, you're dealing with all the different medium, and the issue that makes it even more challenging, not just the massive amounts of data.
Mhm.
There's nothing you can touch and feel. It's like it's an inverse
Mhm.
problem. It's a mathematical inverse problem, just like imaging a
Mhm.
womb. You don't know what's down there, and so it is difficult. It makes it into an art, but there's enough science behind it from what I've seen in my own life that
Mhm.
it's not like voodoo. Like
Yeah.
people drill in a certain place and then
Mhm.
they hit tar and then they hit that and then they hit that and then they hit the reserve and the pocket and it's real. Like it's not a
Mhm.
joke. So
Yeah. You can cross confirm it with a lot of stuff. Like so, what people did essentially is exactly what you said. They would shoot the seismic waves, say okay, and then they would take an actual section where they'd core down and they'd be like, okay, so they've confirmed all these different
right,
velocities
right,
and stuff. But
yeah,
I'm
agreed.
gonna tell you, man, some of that stuff's just I can't believe some of the people can do it. I could never do geophysics. I like math and I think it's cool, but I
Mhm.
don't think it's that cool. Just some of the models they have to use is insane to me.
Yeah,
Just the computers they need to compute thing in like 3D space down to the detail that they can go sometimes is unreal.
just to give you a 2-second thing
Hmm.
on what I was doing at Western Chico was like it was called like a rapid beam migration. So it was like,
Hmm.
let's say you have an image and then you migrate it with a velocity model, but then over time, geologists and geophysicists and the people in the field came up with a better version of the model.
Hmm.
These are open source, so the companies share them with others,
Oh,
and
that's cool.
they get better understanding of like the Gulf of Mexico and stuff. And then so they wanted to do like a remigration quickly. So like you would take a chunk of the migrated image, shoot, rays towards the surface,
Hmm.
and then if it satisfied the ray tracing equation and got to the surface at the orientation of the way that the survey was shot, we would say that we've successfully traced that ray back on
Hmm.
the effects of that model, and then we would shoot it down through a new model. And so that was something that oil companies wanted to pay for and were interested in, so they could get 1 or 2 day updates and
Hmm.
kind of they called it seismic while drilling. They called it seismic guided drilling. So like
Hmm.
they wanted to drill, they experienced some resistance. They wanted to like not just keep drilling blindly in case they hit
Yeah.
something that will damage their tools. And then so they would update their velocity models. And then this
Hmm.
that I was working on, I was largely calling things from a library, like a ray tracing library. So I'm
Yeah.
not the geophysicist who's coming up with all the different
Hmm.
wave equations and all that, but the library that we were calling was very sophisticated and
Hmm.
precise, and all those things that you mentioned, have been verified and are
Hmm.
real. React accordingly if they experience those different mediums, rocks and stuff. So
Hmm.
yeah, it's surprising. I work in directional drilling now, and just the fact that people can like put stuff down there and then randomly
Hmm.
this stuff starts coming out that's useful to us. That to me is incredible. So
It's it's hard to learn some of the stuff at first. Once you get a little ways into it, it does become easier. But just I remember I'll be honest with you. When I started, I just wanted to do paleontology. I didn't care. The only one of the only classes I got a C in my entire high school, or I didn't get a C in the class. I got a C on a test
Mhm.
in Earth science on the rocks test. I didn't care anything about rocks. They didn't interest me. I hated them. And then that school I went to, just the school I got accepted to, I had to do geology. And so within 1 year, I had to learn to love rocks.
Yeah.
But it's I mean they're once you start getting a little bit of understanding, it's really cool. And I think it's neat that you can like there's even like you're not necessarily like the geology background, but you can still get a job doing something that's working with it. I think that's really cool. I hope you enjoy it.
Yeah, I mean, I think the biggest takeaway from that was that something that kind of seemed like voodoo was like a science, and
Yeah.
like there are a lot of people, especially people in interpretation, their domain is very artistic because they're looking for things that are not obvious to somebody looking at a bunch of blips, and seismic and stuff. So they're appreciating, art in their own way. But yeah, I mean, it's cool. Like people, oil companies are willing to spend to make sure that they don't drill blindly. So it's definitely a very important piece of the entire oil and gas kind of excavation, initiative. So maybe, I don't know if you brought that one up, maybe I can ask you a quick one.
Yeah,
Nick?
go for it, man.
Okay, so here I'm famous for this one because, well, actually, yeah, if we have time, maybe I'll do 3 quick ones. But I had a point on the carpenter level. So
Okay.
I think somebody else made this famous, but I tried to not rehash other people's things on my non sequitur. I just wanted to come with my angle.
Yeah.
But this to me is kind of just as solid as the water staying level. To me, there's no way a level carpenter spirit level, which I think there's irony that they're called. It's called carpenter because we believe Jesus was a carpenter and like spirit level. But carpenter level would need to stay level when traversing a curved surface. To me, this is just absolutely nonsensical. I definitely get made fun of that. I don't understand what a carpenter level does, but I can't say I've rubbed it over a curve and it stayed level. Every curve that I would rub it over would move around. But according to baller theory, and I'm not trying to strawman you, but it would be required of a level if it's rubbed over an oblate spheroid of the shape of the Earth, it would not move. It would have to not move because that's what we observe.
Are you talking about like say, and this is not to scale. This is the ball Earth. This is the carpenter level. You're saying if you took it or like SpongeBob brought it around town, it would have to stay level the entire way, right? Assuming no terrain.
Only on Earth. It would have to be only on the shape of the Earth.
Yeah. Only on, like, assuming it was all flat, like you didn't have to worry about terrain.
Exactly.
Yeah.
That's the theory. I think you and I agree. Everybody agrees that that's the way it would work. Yeah. But to me, that's magic. Like that. I'll get made fun of, obviously, but that to me, just I don't have to. I appreciate all the effort that people are putting in particular the guys at Flat Earth Debate, but I don't need anything beyond that for me personally. And so I could be viewed like narrow-minded, and obviously I'm still open to other things. To me, that pushes me 95 to 100% that it's a flat, because a level by definition is only going to do one thing. Like it cannot, like if let's say my phone right here is the level and I put it on my table and I know my table is flat, it cannot then have a double responsibility of like reacting to a curved surface and do the same thing. It would mean that it would have multiple jobs, when the reality is it is only able to recognize a flat surface. And so, not to put words in your mouth, but people will come back with like, you're not thinking about scale or the size of the Earth or whatever. But just with that, what are your thoughts on?
Do you mind if I go for it? So I don't expect to be able to convince you, because I just think it probably is it's just the way you're thinking about it, and it probably just is what it is. But I know you're probably tired of hearing about it's the scale, but the thing to think about is say you take that carpenter's level, right? And say you like, this is my carpenter's level, and this is just for the people viewing. I know you get what I'm saying.
Yeah.
If you bend it slightly, just a tiny, tiny bit, that bubble's not going to shoot all the way to the other side usually. Like you can bend it a small bit and
Hmm.
it'll go up a bit, right? And
Hmm.
so the thing to think about is when we're looking with our eye at that thing, and usually the ones that I've all worked with, they have the two little red lines, and it's like if you're in between these red lines and your bubble's there, you're level.
Hmm.
When you are working with a curve that's that large, right? And
Hmm.
even then, you're gonna have times when the surface of the Earth isn't a nice completely. It's not a completely nice perfect sphere anyway. Like you've got terrain, you've got topography stuff going on.
Hmm.
But like if you think about like as big as it is, like a one atom difference. That's not going to show up on your carpenter's level, and it's not because it's like it's because it is gradational. It's like, yeah, past a certain point, you can definitely tell that you're not level. You can tell that you're off of what the center would be. But if you're only moving that carpenter's level a tiny bit,
Yeah.
that bubble is only going to move a tiny bit, and so they're not super sensitive to really, really, really small scale changes.
So,
And yeah, I'll let you go now because
well, I would say, like, do you agree that, let me just try and word this correctly.
mm-hmm.
Like, we obviously don't have access to an oblate spheroid like the size of the Earth to kind of
Yeah.
play around with, But
Yeah.
let's do this thought experiment. It's like, let's say we were to make a roller coaster,
Mm-hmm.
and it was, equidistant, above the Earth, and it just literally just rode the curve.
Mm-hmm.
That's what its responsibility
Yep.
was for a mile or two. So we could visibly see it curve.
Mm-hmm.
You would have to believe that if you put, like, if you just held that level, and you can get levels, spirit levels on your phone, on your app or whatever, that if you were to like hold that thing or attach it to the side of that roller coaster as it went over this curve, that it would not move if that curve matched Earth curve, which it would if it, the same height. Let's just say it was the same height above the Earth, and it reflected the Earth curve perfectly.
Mm-hmm.
So that to me requires faith, because in my mental thought experiment, I know that it's going to move. It has to. Like there's no way that gravity vectors hitting it orthogonal is going to somehow fix that. Like, so I get your point that it's like small enough or whatever. Let's remove that for now, and let's talk about over a bigger scale, miles and miles and
Yeah.
miles, roller coaster or a levitation train or whatever those things are. Fundamentally, one would have to believe whatever the size of the level doesn't matter, because all that gravity cares about is orthogonality,
Mm-hmm.
or perpendicular to the level itself. It could be a level this big, or it could be a level a million miles long. But as long as the level is the tangent to that surface,
Mm-hmm.
or that roller coaster for this
Yeah.
example, it would have to stay put
Yeah.
while traversing a curve. And to me, I mean, I know that that's not true. Like, I know it. Like, that, if someone showed me that, that would be like, who's that David Blaine? That would be the person doing it. It would be somebody else, like not a mathematician.
Hmm. There's probably not anything I can say. I just for shits and giggles, I came up with this real quick, and now I'm running over my mic. Awesome. So I don't know if you can see this or not. This
Sure.
is basically, and I'm sure this is exactly what you were saying. You were saying that this is what the ball Earth model would say it would do, right? With gravity.
Exactly. That's the perfect description. Yeah.
Okay, so I guess because it's not that it's technically the it is still moving. It's just gonna read level as long as you're, because really all that thing is doing, all that level is actually doing, is telling you that you're perpendicular, more or less perpendicular with the gravity vector, with your main, the summation or the sum of all your gravity vectors. You're more or less perpendicular with that.
Mm-hmm.
And so I don't understand. I guess the thing is you're not in your thought experiment, since you're not starting from like, you're not just going from gravity, like that's not your understanding.
Mm-hmm.
That's probably why you're not, like, when you say that it's not going to do that,
Yeah.
I feel like that's why you're saying that. And there's probably nothing I can do, since I can't convince you of gravity. But it's just because that
Can I grab a prop, Nick? I'm still here,
yeah,
man.
go for it.
Be
No,
right
you're
back.
good. You're good.
Dude, I wish I had a basketball, but I'm a golfer. I'm
Mm-hmm.
getting too old for basketball, but just to use, can you see what I'm holding?
Yep.
So I have a golf ball,
Mm-hmm.
and then pretend like my phone is the spirit level,
Yep.
under level. So if I were to turn, I actually have a level app on this phone.
Mm-hmm.
You know that if I were to turn this over, it would start moving, right?
Yeah.
If I kept the ball perfectly, if I did
Yep.
that, it would freak out.
Absolutely.
Now the question is, this ball has certain properties. It's not an oblate spheroid, obviously,
Mm-hmm.
but let's say I could literally keep expanding this
Yeah.
bigger and bigger to get to the point of an oblate spheroid. Baller theory will say, I'll take my same app on my phone, and obviously this has to be a thought experiment.
Mm-hmm.
Can't do that.
Yeah.
I would do the exact same thing, and it would behave differently. So the only thing that's changed is fundamentally this thing has exploded out.
In your thought experiment, the difference is that when you're doing it in the real world, you've got everything else below it. You've got all the the center of your gravity isn't the golf ball. The center of gravity when you're doing the experiment in the real world's way the hell down there. Like that's like the gravity vector is pointing down essentially.
Fair
Which
enough.
I think like even if you don't accept gravity, you drop that ball. That's the way direction down is the direction that stuff's gonna go. That stuff gets pulled essentially. And
Yeah.
so in the if you were to take that golf ball and if you were to isolate that when it was that small and it's the only thing, if you were to take that spirit level and actually wrap around it, it would if that was your only mass, it would go with that. That's not a whole lot of mass, so it probably wouldn't have a whole lot of pull, but that's going to be the only thing with mass. And so if there is nothing else around it, it would still, even on that small scale, it's going to act the same. And this is the problem that I see with a lot of like the ball Earth and the flat Earth debate is a lot of we don't have. It's exactly what you said. We don't have some other giant ball to go test that's free from the effects of Earth's gravity, or a lot of people just think it's dissident density. We don't have anything to go test against that with. And so there's like I guess for people who the evidence for gravity isn't sufficient enough based on what we already have, that's not a test that you can go and do. And unfortunately, that's usually the test that would convince people. But there's just, you could do it, but you have to go out really, really far into space somewhere where there was probably out of our solar system for sure, probably out of our galaxy. I would think you'd have to go really, really far to get away from all the gravity to be able to run a test like that. But if I feel very confident that if that golf ball was the only mass and you didn't have all this rock beneath us and stuff, that your spirit level around it would actually circle it and say that it was still level. I mean, obviously you have a problem when it's that small of actually being able to have it be 90 degrees because it's going to want to go like that or that, but
Okay, so yeah, I get your point. Like it's not reflective of the Earth, obviously. It's a golf ball, but so I understand it has to be oriented. Like let's say this is the center of the Earth. It has to be with respect to that. I get that because that's the way the vectors are, or the mathematical representation. That's the way they're oriented. So I get that. But you do agree, at least going back to my initial, that was more just a visual. I think we both understand what's happening. But, to me, again, this is still an open question because I'm not, I don't think either of us are going to kind of change each other's view, but we can think about it. And, or at least understand the things that I think about to support my stance. But the thought of like a roller coaster, like I said, because now we're doing it correctly. It's above the Earth. It's the same, orientation, the same center point. If it's done on Earth and it follows, like same height, and follows the created curve. That curved surface has access to these gravity vectors, the same as something that's on the surface. That a level would have to then stay level, traversing a curved surface. Like you agree with that or acknowledge that, right?
Yeah, I think as long as you don't bend it, as long as you don't take it and do that on top of the roller coaster,
yeah. Let's just say in an ideal situation, not including the shaking of the roller coaster, or if you essentially rub a level along the oblate spheroid of the dimensions that are told to us, then it cannot move. And so to me, like if I were to just literally like stand here and like, let's say that this arc that I'm making with my hand, it's not reflective of the Earth curve beneath it, because obviously it would be like basically flat.
Yeah. But let's say it was.
Yeah, it would be basically flat. Like it would, you know, we know that we would need miles and miles to actually see something. But let's just say that this is the Earth curve. You know, we know that if you rub a level on that, it will move. You know, and so if it essentially gets flatter and flatter and then kind of microscopically curved, but still curved, I know the level will move. Like it's not even like a faith thing, or I don't even need an experiment. It's like I know that the level is going to move over a curve. So why would it not move over a bigger curve, just more exaggerated, more broad? You know, like the dimensions of the Earth. I don't see what's going to quote unquote save it from changing its mind, from moving over a curve, even if it's local. And
it's because. So sorry to cut you off. Or are you?
That's
sorry.
That's good.
I was thinking out loud. Well, it's because when you're when you're on the small scale, like the ones where you said you've done it and you know it moves, and like, you know, you've done it and like you take the thing over this and it's definitely going to move.
Yeah.
The on both ends of that, your gravity vector is still pointing down.
Agreed.
But if you were to, and this is all assuming that mass causes gravity. So if you don't have that, there's obviously nothing to do. But we're, for the sake of the ball argument, we're saying for now at least that mass causes gravity. So when you have the curve and you don't have another outside source of gravity, when you've got this, like whatever size the curve is, the gravity vector here is going to point, like, say that this is the curve and this is a perfect semicircle. The gravity vector here and the gravity vector here aren't going to be pointing down anymore. They're going to be pointing inwards because that's where the mass is. So like when you're doing the tests in the real world, you're doing the equivalent of doing it in like that space and jerking the spirit level like really far one way or the other.
Yeah, I agree.
Because it's, I guess that I don't know. I think the thing is that you don't accept gravity. And so that's why, like, per your understanding, that's why it's not going to do that. But
yeah, I think your explanation is if I were in your shoes, like that's what I would say, and I get that, and I'm not trying to like trivialize it or
no, it's fine. I mean, it's like I think you're wrong. You think I'm wrong. It is what it is. So I mean, we're not being assholes about it, so my feelings aren't hurt.
Yeah, so I think that's just so that's the way I think. Like to me, it's like, again, I haven't experienced these in some personal way, like, you know, magnetism, you know, you like wrap, a coil around a nail and you can charge it and like pick up things, you know, you can like experience, you know, other of these other forces, you know, and stuff. But, you know, gravity to me is a theoretical thing that I can only a lot of times, you know, have thought experiments. And so that's one of them that I use for myself, because basically in my mind, like, you know, this is not, you know, obviously Earth curve, but eventually, you know, if like I could recreate, you know, enough radius and had enough room and resources that, you know, I would be able to create a curved surface, very exaggerated, and then just in my mind putting a level over it. It has no hope. Like it's not going to stay level. So, but yeah, you're right with your point that the gravity vectors, if for something on such a small scale, you know, are effectively, you know, pointing in the same direction.
Yeah,
it doesn't matter. Okay, so sorry, I think I raised that one, so I'll put it up to you if you got something to share.
Alrighty, so I think I really just had one more, and then if you want to do a bunch of yours, that's good with me. I just, like I said, I enjoy the conversation. So I guess the last thing that I would throw out, that for me, just from a geology perspective, once again, and that's just because, like, I get all the stuff where people are talking about perspective and whatnot, but they've, you know, Red's rhetoric and Fight the Flat Earth and all those other guys, they've harped on about that so long. If they know it more, if they haven't convinced you with that, I'm sure as shit not, because I like get it, but I don't like know like all the detailed super math for it. So I have to approach everything from a different perspective if I want to actually be able to talk about this stuff.
Yeah.
Like I guess the next thing for me would be the Earth's magnetic field and how it acts.
Mm-hmm.
And so like I'm assuming you're pretty familiar with magnetic fields.
Like refresh. I've
All
learned
right.
at some point. Yeah.
Yeah, so at least in terms of the Earth, the magnet, if you've got a magnet, it's like a bar magnet, you've got a North Pole and a South Pole.
Mm-hmm.
And if you were to draw the magnetic field, it actually leaves out of the North Pole, and the arrows would all wrap around and then go back into the South Pole and then run through that. And so that's what your magnetic field vectors are going to look like.
Mm-hmm.
Yay, vectors. That vector should be in the name of this talk.
Mm-hmm.
Yeah, and so basically, one of the things is, the Earth has a magnetic field, and so we have like a magnetic north, and then so what everyone considers true north isn't the same thing as magnetic north, right? So wherever our North Pole is, which that's the one that most flat Earth maps tend to, they still have that in the center,
Mm-hmm.
but that's not the same as the magnetic north. Were you familiar with that?
No, I didn't.
Okay, cool. All right, yeah. So basically, just the way that the Earth's magnetic field, and this kind of goes, the magnetic field of the Earth appears to have traveled through time, and even since we've been measuring it, it's moved a little bit. So right now, the your compass, if say you just have a compass and you have a needle, if you don't adjust it, it doesn't actually point. It won't point north. It points to magnetic north. So it's actually pointing somewhere, and I think it's in northern Canada right now, somewhere out, definitely out in the middle of nowhere. And that's where magnetic north is. And they think that from what I understand, it's pretty well agreed upon that the magnetic field is coming from the way it's sustaining is its convection current. So the interior of the Earth is supposed to have a hell of a lot of iron.
Mm-hmm.
And so like especially like whenever you're getting those rocks that are coming from deep up under the earth, and you can use those seismic waves to see that there's liquid material coming up deep. The stuff that's from really deep tends to have a lot more iron in it, and so the deeper parts of the earth tend to be really, really iron enriched. And because a lot of that's liquid past a certain depth, those iron, you've got those, I guess those magnetic minerals, you're essentially swirling iron, and that's creating a magnetic field. Probably not too dissimilar from what you're saying, taking a coil around like a needle or something.
Yeah, I just
it's
that in school.
It's the same principles, and just on a much more ridiculous scale and a lot more complicated.
Mm-hmm.
But essentially, so we have a north magnetic, and your compass has to be adjusted for that. And I should have drawn something for this. So on a sphere, this wouldn't be so on a sphere. If you're in the northern hemisphere, your compass is naturally gonna, no matter where you are, it's not gonna point like, I guess, to north. It's gonna point towards it's gonna align itself with the magnetic field of the planet, right? And that's gonna be based on generally where you are. But the problem is, we have a magnetic south pole too, because it's gonna be, we have a magnetic south pole. And I don't understand how on a flat Earth. So I'll show you the drawing, and the letters might be reversed because I drew it normal. But this is just a really, really quick and dirty. I hope I've got that the right way. So the north. Yeah, I've got it at the bottom. That's those. So right now, our the actual. It's weird. The actual south, what we consider the magnetic North Pole, is actually the south pole of the magnet. If that were like a dipole, it's actually the south part of the magnet, but we call it north because it's in the north. And so that's why everything will point. If you have a needle, that needle on the magnet will always point towards. It'll align itself in the direction of the field, and the direction travels to the south. Okay. And so we also, because we have a north magnetic pole, you have a south magnetic pole too. And so on a flat Earth, on a ball Earth, that gives you this. That gives you an actual pole. Like a 180 degree pole. And so you can go to the magnetic south pole as well. I think, I don't remember where it's at. I think it's slightly off of Antarctica, somewhere in the Pacific Ocean, I believe, is where it ends up being. But if you're right over that, your compass is actually, if you let it go where it wants to go, it's going to point straight down to the ground. Whereas if you're at the excuse me, it'll point straight up. But if you go to the magnetic North Pole, it's going to point straight into the ground. What we call magnetic north, essentially. And the problem with that is that relies on being on a pole in 3D space. And so if you were to take the North Magnetic Pole and the South Magnetic Pole and try to plot those on a flat Earth map, you're gonna have like, you know, one pole doing this and then one pole doing this, and then somehow the magnetics have to do that. And this is the on a sphere, all the companies that make compasses, and I've used really high dollar compasses, you actually have to adjust them. And so for the most part, you can't buy a compass that's it used to be separated into 5 zones, and you had to buy a compass for the zone you were going in. So back in the day, if you bought a compass that would work far up north, it wasn't going to work well anywhere else, because it's not just like that straight direction. It's magnetic field in 3D space either way, and that 3D space really matters in your compass needle. Like, does that make sense what I'm trying to say? Like, if you were trying to sit flat on I'll try to show this. Like, if you were trying to use a compass here, it's going to align itself with the field, so it's going to, you know, it's going to want to align itself pointing that way or whatever. And the closer you get to either of the poles, it's going to be more dramatic. And you're not going to be like right on the equator. You're going to be wherever you are. If you're not right on the poles, you're going to be pretty close to perpendicular. And the farther you get from the equator, the less I guess the less perpendicular to the.
I know what you're saying. The density of the flux lines or whatever are more concentrated. So,
and so that thing that's really it's like all the compass companies that make compasses, they have to deal with that, and it was a really big deal a while back. I think it was the company Sunto invented a more or less a global needle that would work in most places, but it had a lot of wiggle room, essentially, is what it was. And that's, you know, they account for a spherical Earth. And I don't, the way that a magnetic dipole like that works, I don't understand how you can have a magnetic North Pole and a magnetic South Pole, and they're like this to each other, not like this. I think that's something that's impossible on a flat Earth. And that's, you know, that's used in navigation. That's used in, I have to use it in my job with an actual compass to actually tell where I am. And I've used a compass on a topographic map to navigate, so I'm pretty familiar with the compass. And it's just those kind of things I don't think you can have, to my knowledge. And this is why I want to talk to you, because you might know the magnetic stuff a little better than I do, like the nitty gritty of that, since you're working with the electric stuff. I don't think that's something that's possible on a flat Earth.
I guess I'll be totally honest. I'm not like I did well, you know, in that course, and I mentioned this in videos, but it was largely like we were solving like magnetic circuits questions, and like it was honestly so hard that a lot of us just, you know, he just kind of diluted the exams, and like he knew we weren't getting it. But what I do like about what you're sharing, like to be honest, what I can understand, and I get something at least, is like I like it because it's like something you can actually like hold, you know, like a compass and stuff. So I guess, you know, if we can not necessarily shelf this, but if you could like maybe crystallize that. And then if we speak again, like just maybe make it like a step-by-step kind of thing, or like, you know, this is the way it works on a local level.
Yeah.
And, you know, even if we don't have access to like these places on the Earth that you're talking about, if one were to do this, they would observe this. And then again, maybe, the way I, even like with me, I'm still kind of early in this flat Earth thing. It's like, I'll put out ideas, even like building tilt is one thing that I've thought of, because, you know, I can see the Houston skyline from my golf course. Like I may not be able to do it myself, but I'll like put it out there and see what people think. And then maybe someone else will do it, or maybe I'll have an experiment that we can like set up. But probably similar with this is like, even if it's like something that you and I don't have access to going to places yet, but if you could like make, and I'm not trying to give you homework, but like as you kind of think about this and like crystallize it as like step 1, do this, step 2, or step 1, this is the theory, the foundation. And then if one were to do this, they would experience this. And then if you have a flat Earth scenario, if I would be in these 2 locations and it would be flat, you know, it would have funny phenomenon or whatever. Like, you could walk me through that next time. That would be cool, you know, and like, I probably, yeah, sorry.
I was gonna say, and I do. I'm sorry. This is I actually ran across this line of thinking and investigating really, really late and preparing for this. And so this is the unfortunately, and this is one of the things I think this might actually be the I think the seismic waves are probably the single most powerful.
Hmm.
But or at least of my, if I were to prove like a ball or if I think that would be the most powerful. But I think this is up there, but unfortunately I found it later. And so that's why I was having a harder time like being able to tell you about the stuff. I don't have any nifty drawings handy or anything to show you. But
I don't. I think your explanation's fine. You're speaking of like real things, so I think you're using a device that we have access to. I think the gyroscopes and all those different things that people are using. I mean, not all of us have access to. Like a level we have access to, and like cameras and stuff. But so that would be a good thing. Maybe I'll hopefully have something as well, like new, like potentially that buildings tilt thing. I want to maybe explore more, and then I can bounce off you. But I think that's a good thing. I think to solidify, your stance and everybody kind of comes at it from their angle. I think the thing that I did post that I hope people watch on my channel is like uniqueness of solution and rigor of a proof. It takes more than one thing. It's like I can't come to you with like a spirit level and say like that's absolute proof and stuff. It's like, well, no, there's another explanation, or you haven't done this on something the scale of the Earth. So that will always be a question.
you have to have a body of evidence, not just the one thing.
Like it's like, unless it's an observation like where you're like out in space and you're seeing it. That's different, But let's say we don't have access to that. Likely we won't. So you need, like I said in my video, you need n linearly independent observations to solve for n variables, and we're solving for many variables. It's not just one. And I think this, like it's not just one thing that's at stake, the radius. It's like
nothing's ever easy.
Yeah, well, you have to explain all the plate tectonics you were talking about too, and you'd have to explain all those things because those could be holes in either of our stories. And so that's a good one. That to me is a good one too, because it's independent of other things. Like it's like the magnetic thing is like one that we know is real and stuff, and then observations of buildings, and sun, moon, phenomena. Those are all independent, relatively, as far as we know. They're kind of, they're not overlapping, double dipping kind of thing. So, that's a good one for sure. I can't say I have anything immediate that would debunk that. I think I would need to kind of maybe, if you walk me through it a bit slower, I might have to like look into some of the stuff that I should have remembered, but that would be good, man. If you do that.
No, and if you have any questions too ever about some of this stuff, just like shoot me an email. Let me know. Anything I can do, I'll let you know what I know. That's all I can do. But like I don't mind. That's like I like talking to people about this stuff. I like teaching this stuff. I like talking about how we know what we know, that kind of thing.
And maybe for the last 15, if we wrap this up, we can go into a bit of the God stuff. I know it's like I want to force you into theology or whatever.
No, but I'm fine with that. I got.
Okay, so obviously I have a few more points that and ballers we can shelf, and maybe weeks from now or month or whatever. If you're if I come to mind, we can have another hangout. But if I guess I'll leave it open for you before I ask a question or bring up anything on theology. Like you mentioned a term that I don't think I understood at the beginning, but like whatever you want to share that you're comfortable with related to your thoughts on the supernatural.
Well, yeah. So I guess my big thing, just to kind of give you an idea of where I come from, in a little more detail, is I don't I'm of the opinion that because the usual way that people tend to define God is they tend to go for omniscience, omnipotence, and omnibenevolence, right? Like at least with the Christian God, that's the three attributes most people would assign to the Christian God. And when I look at the world around us, I don't think that that God can have all three of those at once. I think that some of them, like at least omnipotence and omnibenevolence, I don't think go together very well. So and I tend to personally, because just basically like I look around and like I hear like people say like, because the world is flawed, regardless of whether or not you want to believe that it's because of sin, original sin, or just because that's the way the world is. The world isn't a perfectly wonderful place. It could definitely be better. There could be things that would make our lives easier. There could be more happiness.
Agreed.
And you know, whether or not that's our own faults or because God made it that way, etc. I, at least for me, what I've come to is that I don't think that God's omnipotent and omnibenevolent, because I think if God was, I think the world would be much better, or I think we would have that better, more perfect world. And so I guess my thing, and just where I come theologically, I tend to lean towards I don't think that God's omnipotent, at least anymore, because basically the thing for me that really, like, I guess the thing that I'm hesitant to drop the theist thing. And I tend to think that the only time that God, I don't believe in prayer. I don't believe that God really intervenes in our lives, hardly at all, if ever. I tend to think that God probably doesn't do that. But I do think that God probably, I still tend to accept Jesus. And I think that Jesus was the one time that God interacted with us. I've got a lot of really, really weird theology there. We could probably have a whole episode of some time on that if you'd like. But essentially, I don't believe that Jesus died for our sins, just because for me, it doesn't make sense to me from a lot of different viewpoints. I think that Jesus' death and resurrection was more of a metaphorical thing. So I think, because basically, you know, you had Jesus and the Romans crucified him. They did the absolute worst thing they could do to him, right? Like there was nothing worse than you that they could ever do. And so that the crucifix, that cross, used to be a symbol of fear. Like that's what they did, you know, when Spartacus had his rebellion. They crucified like 500 of them and put them along the Appian Way for everyone to see, and they just left them there. And so that crucifix, that was like a symbol of fear and, you know, don't fuck with Rome, essentially. And now that, because, you know, Jesus died and his message got sent out to everyone, that cross isn't a symbol of fear anymore. And so I tend, it's the symbol of Christianity, and for a lot of people that's hope and happiness and salvation. And I tend to look at it as a much less Jesus died for our sins, because I don't think that a God who would it doesn't make sense to me that a God would send his son and have to kill his son. I would think that an omnipotent God would be able to just forgive the sin on its own. But I think that Jesus' death was a metaphorical thing, because, and essentially in his death, he became the religion of the Roman Empire, the official religion, through Constantine eventually. And so, I mean, at the end, Jesus really got the last laugh. They killed the dude, and then he took their worst thing and made it into his own, essentially. And but I tend to think that that's the only time, because I just don't see any evidence for God interacting. I tend to think that that's the only time. And I'll be honest with you, I don't know why that would be. I don't know why God wouldn't interact with us. That would seem weird. And but the reason, so I say all that, and then you're probably wondering, well, Attila, why the hell do you still believe in God? Because it sounds a hell of a lot like you could totally be an atheist. And for me, a lot of it is because I'm totally willing to buy the Big Bang. A lot of the evidence makes sense to me, but my thing is that there's like the pre-time part, right? So like the Big Bang model, part of the Big Bang is before time, and I don't. In order for the Big Bang to start, you're having essentially, like, without time, there's no cause and effect relationship, because there's not a before and an after ever. And so I don't understand. I can't grasp how something could cause the Big Bang, because there's not time. You can't cause anything. Does that make sense? And so for me, that's what I don't get. And that seems to me like where I'm at, God is the best explanation of that. And I don't know. And so I just think that that's where God created the universe. And I don't know if God, in creating the universe, made it so that it's very, very hard for him to interact with the world. But I tend to believe that I tend more likely to believe that God would be omnibenevolent than omnipotent. And so for that reason, I don't know if God can't interact with us anymore, or, you know, I find it more likely that he can't rather than he would choose not to. But so, and that's basically, in a nutshell, that's essentially my theology.
Okay.
So have fun unpacking that miserable whatever it is.
I mean, I speak regularly on my channel about how and I'm not even trying to label you. Atheism to me, they're just terms. You know, I'm considering myself an atheist for a majority of my life. I mean, I don't think about God when I'm like preparing for exams or going to work, you know, dating or whatever. It's like, I mean, very few times, you know, if I'm driving or if there's peaceful time, you know, before I sleep, or if preparing a video or a lesson, I mean, that's when God comes to mind, or if I'm in pain, to be totally honest. So uh, I vibrate and resonate well with atheists more than the deeply religious people who scare me, honestly, like who just don't want to think. So I get that. I think your experience probably is like mine and a lot of people's. We don't have supernatural encounters, you know. And one guy in the chat is mentioning, you know, things that people have experienced, you know, supernatural things. Some people that I'm pretty sure they're lying, but I can't say all of them. You know, there's been so many, not so many, but I've had enough people tell me things that are supernatural that I'm like, I mean, either they're really trying to, you know, squeeze something out of me or other people, but. So I haven't had that in my own life. So I get your point, but the thing that I was sort of what I was going to ask you, and I think you addressed it, which was the part that I mentioned in my email to you, was the double dipping. And this is just me from an engineering perspective, and systems in our natural world is causal. You know, it's like everything, and this is what I actually like about ball earthers, or not just ball earthers, but scientists. They're obsessed about finding the reason for things, you know. And I got really into like the pickup community years ago when I was like trying to learn, you know, about women and dating, and like I gravitated towards these RSD, Real Social Dynamics guys. They were like an offshoot of the book The Game by Neil Strauss, and like they were obsessed about learning everything about women, like every interaction, like if there was four women with like their guy friend, like how do you handle it? Like they were obsessed about, you know, understanding things. And like to me, you know, that's a very powerful thing to have. But you know, I think that it's very difficult for me to like you know, think of a world that is not causal, you know, or a moment like you were getting at, I think in your what you were saying is that something about the Big Bang or that thing would be a non-causal event. Like it would happen spontaneously, you know, and all that kind of stuff. To me, that is not our reality. You know, there's an explanation for everything, even if that explanation is God did it. I know that that doesn't sit well with a lot of people, but to me, that's the beginning. And I've kind of either directly or indirectly believed this for parts of my life, that maybe we are here, you know, unsupervised, so to speak. But you know, that's where I said atheists are double dipping, is that they are obsessed about causality for everything else. Like if you were to tell them someone got a miracle healing, they'll be like, no, like let me get down to the enzymes, you know, like this is really what happened. Their liver did this, and then it did this, and then, you know, it did that. You know, forget about this supernatural shit, basically, you know. And that's fair. They want causal. They want the cause of the what actually caused the healing, not voodoo and witchcraft, you know, which sometimes it could be. So I like that. But then when we get to like what caused the Big Bang, you know, which you know, there's no answer, you know, and it's not wrong to not have an answer. You know? Like we were talking about gravity, we're still figuring out this and that, but to get too like raw about it and to make it into something that's concrete is disingenuous. And I think that's where I have a stronger feeling that I'm on the right side. And I'm not saying this to sound arrogant, but this is where I think the ball earthers, not you, obviously this discussion is fantastic, but others, just they're very bad PR. Like, because we read people, like, you know, just from our interaction this last couple hours, you get a sense of like what the person is like, you know. Obviously we don't know each other perfectly, but like when you're interacting with enough people over enough time, especially ball earth flat earth thing, you start to get a vibe for people. It doesn't feel right, you know. It's like it doesn't sound like good PR when people are coming across absolutely certain about something that there's no way they can be certain of. They don't even know when it happened. You know, there's debates on the age of the earth and all that, all this carbon dating and all that stuff. It's not down to the day or the moment, obviously. And so that's an issue, you know. And so that lack of causality um, is a problem. And for me, just from a religious perspective, I know, I believe strongly that God is behind it, but then also I don't want to even go to the atheist stance, because it would require me to be like them and to be certain about something that I know no one can be certain of, you know.
Well, here's the thing I would tell you, and I think there are some atheists who won't agree, and there are some who will.
Mm-hmm.
The ones who say that they're absolutely certain can't be. That's you. They don't. You know, you can never be absolutely 100% beyond a shadow of a doubt certain.
Mm-hmm.
You can be like 99.99% certain, and that's fine.
Yeah.
But to say that you know absolutely beyond a shadow of a doubt, like completely 100%, I think that gets into the territory of being disingenuous. And
Yeah.
I think I get what you're saying too, because like what I've noticed that there's a certain type, and I think it's just the type of people who tend to want to come have a lot of these discussions,
Yeah.
or a lot of people go for it for the debates, which is honestly for most flat earthers, I'm going in it more to debate, because I've just seen people who are just crazy. I think crazy disingenuous, and this is why actually I really wanted this to be a discussion, is because you're very very chill and you just want to learn, and I think that's like we can get a lot more out of a discussion than if we just like block off. Here's my 5 minutes. Here's your 5 minutes. Here's my 5 minutes. Here's your 5 minutes. But
Yeah.
you see a lot of the I guess some of the flat earthers, and I'm not going to name names because you know who you are, you ugly motherfucker. But some of them are assholes,
Mm-hmm.
and that's their shtick. That's their character. They like to be assholes. And that's fine, but that's, you know, to people who are coming into this for the first time,
Mm-hmm.
like I one of my students, and I teach labs at the college I'm in, and one of my students was a flat earther, and I was struggling for a long time. I wanted to send him. I think I just ended up sending him to Non Sequitur to watch some videos, but I didn't send him to like Red's rhetoric, because Reds is an asshole. And if this guy has like, you know, he's wondering, and he took the class because he wants to know how we know what we know. It
Yeah.
was like a more of a geography class. But I don't want to send somebody to someone who's an asshole, because unless you're already on that side, it's less likely to convince you, because it comes off as arrogant and like I can't be wrong, that
Yeah.
kind of thing. And so you got to be hesitant to who you send people to. And then on the opposite kind of side of the coin, you get some of the flat earthers who are like that. Like I'll throw it out. That Scotty dude from tonight. What the hell, man? Like he's so sure he's right that he's not even going to let the other person talk, and he won't listen to anything. You got to be willing to listen. Like I'm going to be honest with you. It would be very very hard for you to convince me of flat Earth, but I'm going to listen to what you have to say, right? Like I'm going to hear what you have to say, and I'm going to think about it. I'm not going to sit here and interrupt you and be like, no, you're thinking about it wrong. No, you're wrong. Shut up, man. What the hell? Like I'm not going to do that. And I think unfortunately, because you just the kind of people who want to debate and discuss this thing, you get those people really really bad, which is a shame, because it is bad PR for both sides.
Yeah. I think to defend both sides, I think like maybe Red's rhetoric sort of I don't want to say equivalent, but like maybe like Nathan and some of these other guys come across abrasive. But I do think people like Nathan, just for me personally, serve a very valuable. They're very valuable because we're growing and we're new, and a lot of us are unsure that this is even makes sense, because we're going up against almost everything. It does not leave any stone untouched in a person's life once you cross over. And so, you know, he has to like really, you know, deal with all that resistance, and he's done it himself, and like he's now kind of a pioneer for others. So, you know, I that doesn't mean that, you know, everybody can just, you know, be mean and all that. So I get that, but I do think, you know, Reds has the same responsibility to kind of be the one of the top apologists, you know, for Ball Earth. And I actually, from our debate, I would say he was kind of the most diplomatic with me. I think like obviously it would change if we were to keep going at it more and more, and I'm pretty much like a small timer, but the one thing I do like about him is he has an answer for everything, you know, and like he literally like, it's like he already almost knows what you're about to say. And like I asked him about like the tilt on Lake Pontchartrain, and he had I remembered his answer. He's like immediately he's like, oh, the tolerances and the sensitivity for the devices were not there. And I could have called him out on that further, but he was honestly so nice to me, I didn't want to kind of further. But
he knows his stuff, and when you're doing it long enough, you learn what people say. Like I'm trying really really hard. I'm gonna send him an official message after my channel gets started up and I get a little couple things. I'm trying to get Kent Hovind on there to debate evolution. And I've been listening to that dude for 4 years, and so I have pretty much mapped out, and I'd be willing to bet a lot of money on it that like I know what I can say, what his reply is gonna be.
Yeah. That's cool. That's what I like about YouTube. You get to know a
Yeah.
person. Like people who've seen my videos, they know I'm on edge. You know, I'm a bit kind of emo, but I also think that they know that I'm fair. You know, I'm not out to try and like campaign for
Yeah.
Jesus because I've never had a spiritual encounter, and I think in many ways I wouldn't be a good candidate to have one because it would overwhelm me. You know, honestly. So, you know, but I'm very much a person, like I said earlier, is actively seeking a narrative for our existence, not mine personally, but us as humans collectively and stuff. And I do feel like the Bible offers that. It's to be determined whether it's fulfilled fully and stuff. But yeah, sorry, that
No, are you good?
not quite sure what the. But no, that's good. So I think that oh no, we were talking about personalities on both sides, and I think that yeah, there are. I think you know, I think it is more educational to have this kind of a discussion because like I said, like you and I are both not going to like literally like have a meltdown, you know, if we're wrong. You know, it's like it's going to be alarming clearly because you have your rigorous things that you standing on as true and reliable, and myself as well. So, you know, but it's just another learning point, you know, a major one for sure. But so that Ken Hovind thing, man, it's this is where the ante is really high, you know, and it's a little scary, but once if the ball earth is proven rigorously, then to me the Bible is absolutely garbage. You know, it's like that it supports the flat earth in many ways. I probably am the most upset at people who are ball earth Bible people. That doesn't work for me. You know, it's like, or people who are like you can have appreciation for the Bible and or you can be like you know, a ball earther and have sort of an appreciation or an understanding of the Bible at a distance. But once you get into it, it's very, very obvious that the Bible supports a flat earth, the dome, the firmament, and all that stuff. You know,
it's my understanding that's mostly Old Testament that deals with that, right? Because that's my thing. I think a lot of it, like I'll be honest with you, I think the Old Testament's, and this is me putting it nicely, I think the Old Testament's a pile of shit. I think that I don't think that there's hardly anything real in it. I mean the Genesis contradicts itself between the first and second chapter, and that to me, just like reading through some of those books, even just the way that God is portrayed in those books versus the New Testament was shocking for me. Like, because I came from reading New Testament, obviously, like when I was younger, and then getting into the Old Testament, it's like, look at the book of Nahum. That is not the same deity as what you see in any of the Gospels. Like, there's just in my mind, there's no way. Like, and I can see like even the way they write about God's different. Like in the New Testament, God's kind of there in the background, it seems like, but they never write like God came down and then did this and then did this and then did this. Where it's like in the Old Testament, they write him like he's a storybook character. Like they say that God came down from the heavens, and then God did this, and then God wrestled Jacob, and then God got mad because Jacob was beating him, and so he reached around and hamstrung him, and then he couldn't beat Jacob still, and then just God got really mad. Versus like you never see something like that in the New Testament.
And renamed Israel. Yeah, I get that.
Yeah, so you never see that kind of a thing in the New Testament, and so for me, I don't know, I don't remember seeing anything that would support flat Earth in the New Testament, but
it's not as strong. Yeah, there are some, but yeah, they're not as kind of direct. Like, yeah.
So are you of the opinion then that like if anything in the Bible's wrong, like that it's crap, or is it just that you think it so strongly supports flat Earth that that's like one of the core things, and that's why? Because that's kind of shocking to hear. Is that if flat Earth was wrong, if we proved that flat Earth wasn't the case, that you'd reject the Bible? That's really really surprising to me.
Dude, I learned the Bible on a hangout, like, and I would have no shame or regret in doing that because to me, a book like that, even if the flat Earth is true and it ends up being true, but like the mark of the beast doesn't happen, like I've mentioned in my videos, if that doesn't happen and it's just lingering or just doesn't honestly happen, like the governments don't force it, that's a deceptive book. To me, that is all the evil that's happened through religion makes sense because the book is confused in and of itself. So it would create confusion and evil and leverage and all that, you know. So like to me, I would be embarrassed that I even read it, even though there are some good things about, you know, God forgiving, you know, asking us to forgive. But there would be a lot of other things like you're probably getting at with the Old Testament in particular that are extremely confusing, you know, and might hurt you more than will help you. You know what I mean? If what I mean, there'll be more weird stuff to overcome than just God telling you what should be kind of common sense, you know, like love your neighbor and like forgive people and stuff like that. So, yeah, I mean, I think that's where the stakes are really high. That's why, you know, again, to reiterate, you know, these discussions are good, especially when they're civil, you know, because, you know, the implications are real. For me to go back to Ball Earth, you know, just from a personal perspective, and especially the people now who are in flat Earth, standing on the Bible, or at least having the Bible kind of next to us, we go back to our old life, but we don't bring the Bible with us. The Bible's gone now, you know, and it's like, then there's like a process of elimination. To me, the Quran is gone because I don't see the Quran as being any more or less virtuous than the Bible, possibly less, but I'm not trying to offend, you know, Muslims. But, and Judaism to me is a subset of both of those religions. And again, I'm not trying to trivialize it, but it is, you know, a subset of the scriptures. I'm sure there's a little bit more around it, but it relies on Abraham, Isaac, and Jacob, and all that, you know, fighting with God and all that stuff. And those are gone. So now I'm like left with going back to Hinduism potentially, where my family's Hindu, Buddhism, or I honestly, I probably would reject any kind of formal. I would not put more energy towards seeking out a religion at that point. I would just be like trying to like just, you know, live like a virtuous life, or, you know, be around people, you know, who are comforting and all that kind of stuff. So I would just give up the whole search entirely, because I would be like, dude, I just wasted so much energy in my life on all these books. It's like, I'm just going to go by what I've experienced, you know, math, science, physics, stuff like that.
If that happens, what I would recommend you do, look into and you might want to look into it just because I think you'd find the philosophy behind it interesting. Some of the Eastern things are less religions, more mindsets. I think it's like Taoism is one. I've got a buddy who's he's very, very Christian, and he believes in the Bible much more so than I do. Like he finds a use for the Old Testament, whereas I don't. And I think it's Taoism that he's really, really interested in kind of applying that philosophy to his life. And he's found it actually works quite well with his Christianity, because it's not necessarily a religion; it's a mindset.
Yeah, that up. That's
that
cool.
I don't know. That might be interesting to you. I don't know why that thought just popped into my head, but
yeah, I think just so you probably know from my channel that, you know, think that the mark of the beast is coming out soon. I guess I'm curious, and I'm not trying to put you on the spot or embarrass you or anything, but let's say hypothetically the government does require you and I to access our money, put something in our body, wherever it may be. Let's just be general for now. Would you, what are your thoughts on that? First of all, does that just sound ridiculous?
I think that Singapore would be a great place to live.
Let's say it was worldwide.
They can, if it's the world.
Because the prophecy does explicitly say it has to be all. So but
I wouldn't do it. I just think to me, it's not even a like mark of the beast thing. It's just you know, I really don't like the idea of any sort of government telling you like, hey, you have to put shit in your body. And it's not like, I'm not one of those anti-vax people. I'm fully on support. Vaccines work. I think, you know, kids should have to have them, but because that's different. That's actually doing something to protect you. That's not making you put a physical thing in your body in order for you to do something that you could do without it. Like I don't think it's likely to happen. I'm not because I'm not like super, I guess. I wouldn't describe myself as religious. I'm probably more spiritual, just in what I've described to you. So I tend to not believe that any of the prophecies are very likely to come true. I'll be honest with you. I haven't read them all though, so you never know. But I think that a lot of them that I've heard are probably vague enough that it's whatever. And you know, and I don't think it's something that's happened. If I were to bet my life right now, I'd bet it wouldn't. But it, you know, it maybe. I'd say probably not. I don't think that there's much danger of it, but I'm certainly not letting a government put some shit in my body. So I guess at that point it becomes resistance time.
Yeah, I think that's I'll be totally honest too, and I've said this in videos. I do find it hard to believe that that will ever be likely, because people on both sides, whatever those two sides are, not even saying ball or flat Earth, but like all sides, I don't think that people would do that. Like, just that doesn't make sense. Like that,
Yeah.
a government would ever have the ability to, like, have that much influence, on people, and require that when there's already other ways that they could accomplish that without the need for something physical. So but that's what it states. And so to me, like, that's there, and just the likelihood of this happening way down the road, to me, just doesn't seem plausible. So to me, the Bible, the rubber is hitting the road in many ways with that, and with the ball or flat Earth thing. So like, if the Earth is a ball, that prophecy, even if it happens, is irrelevant, because it's just a coincidence. It's like, or it actually serves the purpose that the government is saying, just to, like, keep track of people and to not have crime or whatever story, and all that. And it doesn't matter, because it's not the God of the Bible who's going to, quote unquote, punish you for that. But if it does happen globally, which is like a major part of the prophecy, so you can't kind of escape it. I implore people to, like, double check the math, so to speak, for lack of a better phrase. Because I think it's still, at that point, I suspect it'll still be a faith issue, because if I were to be God, and this is blasphemous to say, that if I were to make that a prophecy, I wouldn't make flat Earth known with 100% certainty, because the God of the Bible at least always requires faith, and I'm not trying to preach to you, but, like, this is a strategy. Like, God would not make himself 100% known certain, because then people would just be, like, doing it or not doing it for that. And so I think there'll always be an element of faith and resisting for the right reasons, which I think what you're saying is the right reasons. But I just ask, to keep that in your mind, that we definitely, from an engineering perspective, we can do it, like, from the technology, the coordination and all that. And that's why flat Earth is important from the God exists perspective, but has a higher level of importance, just like the moon landing, which I believe is fake, means that the coordination, the governments worldwide are coordinated, and that the only way that prophecy can happen, if that's true. So if there is no coordination worldwide, it could still happen, but it would have to happen way down the road. Like, it could not happen soon, because that coordination would need to happen at some point.
I kind of like, I think we're in an interesting time, because it seems like it's looking less and less likely like world government's going to be a thing, which is, 10 years ago, it looked more and more like that's the way we were going.
Yeah.
But, it's just the US is pulling out of stuff now. Brexit happened. It's almost like stuff's kind of going away. I'll be honest, I at least hope I was my birthday is November 1st, 1993, and that's the day they signed the treaty for the EU. And so I'm just really, really hoping, one of my goals in life, I want to outlive the EU. So I was, like, super, super cheering for Brexit, because I just want the EU to go away so I can say I outlived it.
That's crazy, dude.
Just a silly thing. But
next time, man, I'll try and have better stuff if you want to get into prophecy. But there are verses that allude to the EU being formed and then the EU being dissolved. But I'd have to, like, dig in.
I'd be curious to see.
Yeah, so I'll put that on the list of things I need to research a bit myself. I didn't get to bring that up in my last non sequitur debate, because I think that's in the weeds, like way in the weeds. Like, people could just be like, they already know that I'm out there, so that would be is way out there.
I wish like that's one I think would have benefited from being more of a discussion, because it was kind of frustrating. One of you guys would start, like, going into it, and you would just start to really get into the meat of what you were saying, and I would hear that damn buzzer go off. Like, 5 minutes isn't a whole lot of time. And so I really do, for any kind of getting things done, I really prefer, like, a discussion.
Yeah, non sequitur is I enjoy that interaction, even though, like, we're kind of jawboning in the chat box. But to allow someone like me to start talking about Mark of the Beast and stuff and orthogonal vectors, which I think people get now. I think you and I have, maybe I could have done a better job of explaining it, but you know,
that's something that's hard to explain to people. Like the difference between what or how you're using orthogonal and then what most people like. It's like I went for the 90 degrees because I like 2D
right,
space,
right.
but like actually describing that to someone in the way that they understand what it means, it's a hard concept.
Yeah.
So
But I think
I
it's a
couldn't do it.
platform. I think for that, just as like a starting point to maybe spin off, discussions like we're having. So, um, yeah, man. So if you have any final thoughts, and then let's link up again. Be in the loop on
Yeah,
how.
no, that'd be I think it'd be cool if just every once in a while, even if it's a couple times a year, just like maybe like pop in and do a hangout and just talk to each other and chill because I've really enjoyed this.
Yeah, dude,
Like,
you can host the next one, man. If your channel's up, that would be cool. Let's do
sweet,
that.
yeah, it better be up by then because I'm wanting to before school starts back, so before like the middle of January, I've got a couple videos scripted out. I really just need to get a green screen so that everyone's not looking.
Mhm.
Right now I messed with my camera and put it up higher so you can't see my cool shark poster in the background, but
Mhm.
I need to get working on it because I've got videos. Like I'm gonna cover a little bit of everything. Like I'll probably stay away from flat Earth for the most part because that's something I just want to debate like every once in a while. Like maybe something like this, or
Mhm.
I'm still waiting. I'm gonna go in with all this geology stuff a little more refined, and because actually last Saturday the night that we started talking in chat,
Mhm.
some guy was supposed to debate me and he bailed last minute,
Oh,
and so yep.
oh, cool.
So
Okay,
yeah, because I had actually emailed Kyle and got in touch with them. It was
nice.
after one of the it was whoever went the Saturday after you. They had someone on there, and I was like, "Oh man, this is just bad. I need to get in there with some geology because I'm really tired of hearing about perspective over and over and over and over again. It's not convincing either side. So I just wanted to throw something new into the mix. But yeah, and so I didn't get anybody. But I'm gonna cover a little bit of everything. Like I used to be a big ancient aliens person. I'll be honest with you. Like I used to be that guy. Like I got to high school and I couldn't wait to tell my roommate, "Hey man, you ever heard of Puma Punku? Ancient aliens, man. Ancient aliens, pyramids, bro." And
Yeah.
I'll never forget. He put his hand on my shoulders like, "Nick, I've got a video for you to watch." And he
Hmm.
linked me to Ancient Aliens Debunked. And I knew just enough geology by then to realize that everything that they were saying was they were straight up lying about stuff.
Huh.
And I was able to like research it and confirm it. And so and my dad's still kind of an ancient aliens guy, and so I have a special place of hatred in my heart for it. But I found a couple people who specialize in that kind of thing, and I'm probably going to be like just another Logic rip off if you ever heard of Logic.
No, I haven't.
Probably kind of like he's a big, I guess, mostly atheist YouTuber, but he does a little bit of he's mostly like argues against atheists and some pseudoscience stuff. So I'll probably be in that vein of something. I need to get me a green screen so people don't have to look at that and stuff. But
I do like atheists like ragging on the health and wealth religious people in particular because they deserve a lot of ridicule, in my opinion. That's like the deepest evil that can exist with.
health and wealth, are we talking about like Jilly Juice and stuff?
Or there's like pastors who are kind of in it for the money, like the Creflo Dollars and the Joel Osteens and TD Jakes and all that. Like they're just excessively over the top, just trying to siphon as much money as humanly possible, into their ministry. And
Yeah.
I'm not sure if it was Logic, but there's a guy like an atheist channel who just takes their videos and just like makes fun of them. And I'm like, I find that like super.
It could be there's a guy, Jeff Holiday, deals with a lot of people like that.
Okay. I remember this guy was like literally drinking wine and like just kind of like just roasting religious people. And like, I just found it, necessary.
There's
And
some really good channels out there. It's really frustrating when people take that kind of thing and they use it to make money. Like that's like it's one thing if you really believe it and that's why you're peddling it. But if
Mhm.
you're peddling it because you're Kent Hovind, this is you. This is you I'm talking about. If you don't actually believe what you're saying and you're peddling your shit just to make money, you're a
Mhm.
terrible person because you're literally misguiding people and lying to people just for your money. And that's like, don't do that.
That's true. I mean, Jesus even said that those with, light that ends up being darkness exhibit the deepest form of darkness. And I think that
Oh,
they fall into that camp.
that's a good quote.
But All right, Nick, man, thanks again for your time,
Yeah,
dude.
no, I appreciate. Thank you for having me, man. I really appreciate it.
So there's one guy in the chat who was asking for your contact, so I'll just forward you his email and you can get in touch
Yeah.
with him. But
No, that's gonna be anybody who wants to just send that. It's you can put it in your description if you want. It should be Attila the one videos at gmail.com. Anybody has any questions about anything, email me. I'm free to chat.
okay. Do you want to say your email again in case people want to, or if you're comfortable sharing it this way?
Yeah.
Or
So
okay.
it's Attila the one videos at gmail.com. Is that right? I just started using it when I contacted you because I made it for the YouTube channel and
Okay.
then never used the email. And so I'm pretty sure that's what it is. Let me make sure. Yeah, it's Attila, two T's, one L, the one videos. That's all one word at gmail.com.
Yeah.
And that's if you've got anything about this, just feel free to shoot me an email. I don't bite.
No, that's cool. I'll forward you what I don't know what he wanted, but I just wanted to run it past you first. But
Alrighty. No, that's totally good with me.
all right, man. So thanks again for your time, and look,
Absolutely.
keep me posted on how things are going. And
Alrighty. You as well. Let me know if you find out anything new. I'm curious.
yeah. All right, man. We'll talk soon.
Appreciate it, man. Take care and you have a good night and good rest of the year, I guess.
Have a good 2019, dude.
You too. I'll hopefully see you around.
Yeah. Take care.